This plenary session this morning. We are a little late, sorry for that. I am really pleased and honored to chair this session. Our first speaker is Dr. Khalil Amin, and his presentation will be on high energy and high power electrodes for automotive battery applications. I should say some words about Dr. Khalil Amin, who is quite well known. He is at the Argonne National Laboratory, quite well-known institution in the States. He is a distinguished fellow and director of the Advanced Battery Technology team. And he is directing the research and development of advanced materials and battery systems for both military and medical applications. Dr. Amin serves also as a committee member of the U.S. National Research Council of the U.S. Academy of Science on battery-related technologies. He is also adjunct distinguished professor at Stanford University, Hong Kong, University of Science and Technology, Peking, Beijing Institute of Technology, and Nanjing Science and Technology Universities. Dr. Khalil is a 2003 recipient of Scientific America's top worldwide 50 researcher. And also 2009 recipient of the U.S. Federal Laboratory Award for Excellence in Technology Transfer. 2013 DOE Vehicle Technologies Office Award, and the 5-time recipient of the R&D 100 Award. Dr. Amin holds over 176 patents and patent applications and has over 439 publications with a Google Ash Index of 88. From 98 to 08, Dr. Amin was the most cited scientist in the world in the field of battery technologies. He serves as the president of the International Meeting for Lithium Battery and also chairman of the International Automotive Lithium Battery Association and associate editor of the Journal of Nano Energy. Dr. Khalil Amin, welcome. Despite his ligament problem, he managed to come, and I would like to thank him on your behalf. Thank you. Dr. Khalil.
Thank you, Mr. Chairman. I really appreciate the introduction. And I would like also to thank the organizer, especially Dries, Diba, who invited me to share with you some of the work we're doing at Argonne National Lab. I'm very sorry I can't stand in front of you because I broke my leg, so I'm in the recovery process, so please excuse me. Today I would like to share with you some of the work on developing advanced chemistries for automotive application. That's the task that we were given by the Department of Energy, and Argonne is the leader in this area. I have talked to my colleagues on the way back here, and I was told I have to put some more business information as well, at least to show you that the phosphate material has a big future in this field. Okay, so I'd like to start with this busy slide. This is the 2009 Global Human Activity Energy Flow. The message here is very clear. All applications, either residential, commercial, or industrial, rely on many sources of energy, as you can see here, from hydro all the way to natural gas and oil. There is one application, which is transportation, that rely on one source of energy, which is oil. And the story doesn't end up here because half of the energy is wasted in heat. So not only we are relying on one source, but we also, not only on our source, but we waste half of it. So this situation is very unsustainable, obviously, in the future. So this is one of the main reasons why we have to think about electrification of vehicles. There is another reason, which is, at least in the United States and China and in Europe, United States basically consume about 20 million barrels a day of oil, and 72% of that goes to transportation. So if you really want to make an impact, we have to make sure to accelerate the commercialization of electric vehicle. And another thing which is more of a general concern of all of us is greenhouse gas emission, as you can see here. This is the CO2 reduction glide path in a long term. So if you stay as business as usual, you will see that within 100 years, the CO2, the atmospheric CO2 concentration can go to 700 ppm, and that translates in almost 4-degree increase in the Earth temperature. So now you can really think about some real climate change. So if we make, electrification as our mission, we should be able to stabilize this number to where the industrial countries has agreed on. It's 450 ppm at the Kyoto Protocol. Now, fortunately, electrification is underway. And here is one reason, is basic regulation. In the United States, there was a law that passed during Obama administration that mandated 54.5 miles per gallon. I'm not sure this law will stand now with Trump, who is more of an oil and he's not really a believer of the climate change. So, but Europe and China are very aggressive and moving forward. So you have Europe, which is giving 58 gallon per mile per gallon by 2020, and China, which is obviously because if you go to China, you can see the reason why the pollution is just unbelievable. So they are making a big effort in trying to address this. And the great things about China, this is very powerful, I would say, government. So if they say things, it will happen. So, and they have actually mandated 56 miles per gallon by 2020. So, and I see because of these two, United States has to follow, because most of the car industry in the United States make more money in China than in the United States, like GM and Ford, for instance. So I don't see any return to dirty technology of, from the energy point of view. Also, I have to give a lot of credit to Toyota Motor Corporation, because they are the one that started the commercialization of hybrid electric vehicle. This is very simple system, and that's the reason why you see tremendous acceleration of commercialization of hybrid in Europe and in the United States. And the reason is because you have a very small battery that you add to the vehicle. You still have an electric motor, engine, and a tank. The battery will mostly assist the main engine during acceleration, but most importantly, it will recover the energy that you usually waste in heat when you brake and charge the battery. So that's one of the reasons why this system is low cost, because the added cost of the battery is very small. And you can buy now a Prius for $19,000, for instance. And I think the expansion of Prius and other technologies from other companies has grown significantly to millions of vehicles now. In the United States, our target is the plug-in. The plug-in, as you can see, you need to have very large battery. And this battery has to be able to allow you to go all electric to your work and come back. And if you change your mind, you can apply the hybrid system, so you can use basically gasoline coupled with the electric motor. So because of that, you have many technologies. You have an internal combustion engine, you have an electric motor, you have a very large battery, you have a transmission, and you have a tank. So for that, the amount of technologies within a very constrained volume is very, very high. And therefore, the energy density requirement for battery is very, very severe. It's actually more severe than electric vehicle, where the battery is the brain of the vehicle. Basically, you don't have anything else. So here we are targeting 40 miles, because in the United States, 75% of the commuters commute within 40 miles. And that's very, very challenging. The applications are very significant. you have lithium-ion, for instance, has dominated the consumer electronic. The next big application is the vehicle, electric vehicle, and the grid. So you go from watt-hour to kilowatt-hour and megawatt-hour. So there is a tremendous amount of expansion for the people who are developing, for example, materials that goes in batteries. This is just a forecast of the hybrid and electric vehicle in the world. You can see different forecasts. Some people are targeting, for example, within this is very old, 2014, there will be 2.5 million. And I think this is very conservative because now the hybrid, there is more than 5 million vehicles in the market, if you take Prius and GM and others. So very conservative forecast. On electric vehicle, by 2020, you expect 5 million vehicles. And those are large batteries that goes in electric vehicles. So tremendous amounts of material will be needed for this application. And here is the growth of plug-in and electric vehicle sales so far up to 2015. You can see between 2014 and 2015, the plug-in has went up by 48%. Now, the amount of vehicle is very small. It's only 250,000 vehicles, absolutely, comparing to 80 million vehicles that get produced and sold every year. A big chunk of that is in China and Europe and the United States. So you can see China is really dominant because the government is putting tremendous amount of subsidy and funding to advance the technology. On the electric vehicle, the growth is about from last year to this year, 2014 to 2015, is about 61%. And as you can see, China is the dominant. The good news is China is using iron phosphate, which is something that of interest to OCP. So there is an opportunity for a big business here. This is the worldwide battery market. It's about $65 billion. Mostly is in consumer and storage for, how to say it. The lithium ion here is eventually taking over the nickel metal hydride batteries because the big chunk of the batteries for nickel metal hydride goes in the Prius for hybrid electric vehicle. So once they switch to lithium ion, you see tremendous opportunity for lithium ion market-wise, actually. And these are the application. And you can see, for example, for automotive, it's still very small. There is a tremendous amount of growth in the future. And these are, for example, as I mentioned, the different applications. You see the automotive is here, the portable and other applications are the biggest business at the moment. So we expect within the next 10 years, the automotive business will grow significantly with the opportunity of reducing the cost, obviously. You will see tremendous growth in hybrid and plug-in hybrid and electric vehicle. And this is regarding specifically to lithium ion. You can see at the moment there is almost production of 5,600 million cells at 60,000 megawatt hour at the moment. So, and these are mostly consumer electronic, laptops and computers and so on. The battery for automotive is still very small. I say it's mostly dominant by China, which is really the leader in this area at the moment. Now, as I mentioned, lithium ion is very attractive because it provides the highest volumetric and gravimetric energy density. In another word, you can make batteries smaller, lighter, but yet very energetic. There is a big, how to say it, square here, which means the technology is very versatile. You can develop different cathode, anode, electrolyte, different system, high voltage, low voltage, and so on. Unlike this system, which basically the chemistry is very fixed. You just have some dopant to improve the performance. So there is an opportunity here. And for people who doesn't know what is the concept of lithium ion, I have a small schematic representation. You know, the lithium ion has a cathode which has a layered structure where lithium is sandwiched between metal oxide slabs and has carbon as the anode. Carbon also has a lamellar structure. So during the charge, lithium will move and will be conducted through an electrolyte, which is a non-conducting media, and intercalate into carbon. And the electron will move this way. And then during the discharge, the lithium will go back. What happened? So basically, in my back, and then the electron will go and basically power the device. It's very simple. So it's a very simple concept, but when you charge these electrodes, they become extremely reactive. So what happens is you have tremendous surface reactivity, which are very difficult to understand and make the system really very complicated. So stabilization of these material will alleviate this problem. So these are the major components that are commercially available now. You have the layered oxide in consumer electronic. We've seen now some penetration in automotive. You have the spinel, which used to be the introduction by GM for Chevy Volt because it has some safety consideration. And then you have the iron phosphate, which is mainly dominant by the Chinese in mostly electric vehicle and electric bus, which is a very big program. And as I mentioned, the carbon is the material of choice for anode in this case. So you can see, for example, the iron phosphate has lower voltage, fairly decent capacity. So some of these materials shows much higher capacity than the iron phosphate, but as I will show you, this material has outstanding safety characteristic, and that's the reason why it's used in large format battery for buses and electric vehicle. So obviously, there is still some work to be done. So there are some key barriers. One of them is safety. You need inherently safe battery. And the other one is cost, because people need to be, the technology need to be affordable. So let me show you one video. Can you click on this one? I'm not sure if you can. I don't think so, you hear me. Can you click on this? Hello? It's okay. So you can see once you have a nail penetration of a 10 amp hour cell, actually, which is for hybrid, nothing happened. There is barely any evaporation of solvent, so the heat is very minimal. This is an industrial way of testing. Now, if you take, for example, the NCA, which has high capacity, this is a smaller cell, so the amount of energy is smaller than here. This one is using a Tesla Motor Corporation vehicle. So please click on this one. This is what you get. Because this cathode is extremely reactive when you remove lithium. You have nickel 4+, which is unstable in an oxide phase. So you have an immediate decomposition and generation of oxygen that react with the electrolyte, which is extremely exothermic. So you end up with a thermal runaway. And that's the reason why the Chinese are using this system, because of its outstanding safety characteristic. And one of the reasons is because the PU bond is very difficult to break up. So there is no oxygen release in this case. So it brings me to the iron phosphate. I'm going to mostly focus on the iron phosphate. As you can see, it has many benefits. You have phosphate and iron. These are the cheapest element. So cost-wise, it's very attractive. The PU bond is very stable, so there is tremendous amount of stability in the material itself. And I just show you the thermal safety is outstanding in a real test using a hybrid battery cell. It has a lower potential comparing to the oxide, but not that low. 4 volt versus 3.5 volt. Capacity is fairly high, similar to the oxide. So the advantage here, when you remove lithium, you charge iron from 2 to 3. And iron 3 is the most stable form of iron. So you don't have reactivity with the electrolyte. When you go higher in oxidation state, the reactivity goes up. So these are all very attractive characteristics, but the problem, it has very poor electronic conductivity. This is a serious issue, because if you really want to move lithium through the particle, it will be very difficult, and therefore you cannot achieve good performance. And one way to address this is to use nanomaterials. So basically you reduce the pathway of diffusion within that particle. So when you do that, what happens is you create an issue of density. The packing density of the material becomes very low, and therefore the energy drop. So what I would like to show you today is there is an area, an idea to fix this problem. Before I go, I just show this slide that I took from one of the study. This is in 2014. 2013, you can see the cobalt oxide is a dominant for consumer electronic. The iron phosphate was very small, 8%. And by 2015, you can see, because of the expansion of electric vehicle in China, it went in from 8% to 23%, and the expansion is growing at 8% a year, basically. So there is an opportunity with this material. Now, you can make this material with different ways: solid-state reaction, ball milling, carbothermal reduction, hydrothermal, which is very dominant now, and spray pyrolysis. I'm going to show you that this could be an interesting opportunity to make very dense iron phosphate to take care of the energy problem if you increase the density. Here is one example that just to show you the importance of nano and also carbon coating in improving the performance of iron phosphate. So in this case, we use this type of precursor mixed with lithium carbonate. You calcine, and you do a second calcination, and then you end up with you do a carbon coating, obviously, and you end up with a green powder to black powder. I'm going to show you how to do the carbon coating. A lot of people use polymers or carbon mixing. Here is a much clever way, which is using propylene or toluene, because it's a gas. Gas go everywhere, so you basically can end up having contact with all the particles, not just surface contact if you do a normal mix. And you can do that easily at very low temperature. You crack basically propylene and you form carbon at the surface of this nanomaterial. Here we have basically a particle that is 300 nanometer that give you fairly good performance because the pathway of lithium diffusion has been shortened. So it's much easier to move lithium out than if you have a micron type particle like in the oxide, where the density plays a very good role in energy. But unfortunately here, if you use nanomaterial, your density is very, very low. You can't pack active material in the electrode and therefore in the cell. So that's a challenge for the iron phosphate. Because if you have low energy, you have to put more barriers, and that increase the cost of the full pack. So to understand how much carbon we put with the cracking, you can just use a TG. It's very simple, TGA. If you basically heat up the iron phosphate, you basically oxidize it. You form this phase, which is a trivalent iron, and that the associated gain weight theoretically is 5%. Now, if you have carbon there, so once you do the same things, you increase you basically increase the weight, and once you start burning carbon, you drop the weight, and the difference is the amount of carbon that you have in your material. It's very simple. In this case, we have about 2%. In general, when you have nanomaterial, you have to put 10 to 15% of carbon, and that also can affect because you put in inactive material in the electrode, and that affect the performance of the cell. But with this clever cracking of toluene or propylene, you can put very tiny amount of carbon, less than 2%, and the performance is very outstanding. This is an X-ray that shows that the coating does not affect the overall bulk structure of the material. As you can see, before and after is exactly the same things. But if you look at the impedance, which is very important for power, you can see, for example, if you use a Canadian company that sell this material, they use about 10%. The impedance is very high. If you use, for example, most of the industry is using iron phosphate with 15% of acid and black, you basically, because you increase the carbon amount, you get more contact, electric contact, the impedance drop. But with our process, we use only 2%, so the amount of iron phosphate is much larger here. You get much lower impedance, so therefore more power. So because gas-solid reaction is the best way to create a good protection and good surface coating. And performance-wise, the material performs very well at high temperature and room temperature, and this is in a full cell. We have data that shows thousands of cycles. I couldn't find it because it's a little old. But the bottom line is when you do a nice carbon coating, you can get very high rate capability with this material. Now, nanophase, as I mentioned, can deliver significantly high power, but the problem is the poor packing density, as I mentioned, because it's nano. So that basically results in lower energy because you don't pack as much active material as you need. So how can we address that? And here is an example that shows a battery, how big it is. This is the dimension of the battery. It's 18650. The capacity is only 1.1 amp hour. And if you take the lithium cobalt oxide, which has about 5 times more density, practical density than the iron phosphate, a tiny battery give you more than 2 times the energy. So that's the problem. Huh? So the idea is how can we address the density to increase, you see, is 1 gram per cc versus 2.6 gram per cc density-wise. So we need to bring this material higher to increase the density, increase the energy density, so you can reduce the cost and make this technology much more expandable for electric and plug-in. So, and to do that, we decide to go with a new process. It's a co-precipitation. We want to synthesize micron-size iron phosphate. So if you do that, obviously the pathway diffusion become very long and the performance will drop. But we want also to put in a clever nanopores through the particle. So, and I will explain why it's important. To make this material, this is a process that uses phosphoric acid. I know that the OSOP is the largest producer of phosphoric acid, so there is an opportunity with this. And you use a cheap iron 3 type nitrate material. You put it in a reactor, you use a chelating agent and co-precipitating agent, and you form this phase here, and basically you dry it, you filter it, you form FePO2, and then you lithiated it. And then you do the carbon coating using the process I show you. So this is how it looks. Its material is spherical, as it showed from here. So obviously it's 5 to 6 micron, in some cases 10 microns, so we're talking micron size now. But when you do the cross-section, you get like a brain-type morphology. So we created nanopores across the particle. And the idea is when you fill the electrode with the electrolyte, these pores will be filled with the electrolyte, and therefore lithium here, instead of going all the way here, will come here and fly very fast out of the material. So you should expect very good power capability without affecting, you should get very high energy without affecting the power performance of this material. And of course, you can do the coating, as I mentioned. This is, you can do coating at the surface and within the pores. And the best way to do that is cracking propylene or toluene gas, because gas go everywhere before you can basically decompose it. As you can see, we have carbon at the surface of the particle and carbon inside the pores for better conductivity. And this is a PMA that shows the carbon is everywhere, not only at the surface of the particle, but inside the pores as well. So how about the performance? So this is the gravimetric energy density of a 200 nanometer iron phosphate versus 6 micron. Obviously, it's gravimetric. The capacity is the same. But look at the volumetric, where the density play a big role. You can see we almost double the volumetric energy density. Now we are very competitive with the oxide. And this material is not commercially available, so I'm hoping we can do it with the OCP folks and the R&D folks here. It will be very interesting. And you can see now we move from 100 milliampere per square centimeter to almost 250. So now that we can talk about some real density, you know, that are very similar to the spinel, for instance. So, and the volumetric density basically more than double in this case. So how about the power? Because that's very important. You know, if the power is not that great, then we don't have a case. And here is the gravimetric capacity versus C rate. When you go at very high rate, when you charge and discharge at very high rate, we're talking about, and this is with the nano versus micron. You see they're almost parallel, very, very close. So we did not affect the power capability of this material. And this is the volumetric capacity when you do fast charging and discharging. You can see clearly that the energy is much higher with the micron size iron phosphate versus the nano. And the power performance is very, very, very good. It's just parallel, basically. So we did not affect. The bottom line is the performance is not affected because, as I mentioned, the lithium inside the particle doesn't have to go all the way out to the edge. It will just seize those pores, and then the pores are filled with the electrolyte, and the conductivity of lithium through the electrolyte is much faster than in a solid, where you have just a diffusion. Now? And here is the impedance. It's almost similar. So the bottom line is this material could be suitable not only for electric vehicle where the power is not very significant, but also for for energy, and like in plug-in where both the energy and power are necessary in this case. And these are some of the performance at different rate and different temperature. As you can see, they are very, very acceptable and very similar to the oxide, which are used now in automotive application. And these are some of the cycling performance. As you can see, at different temperature, is very stable. It's very stable is because of the nature of the material. You know, iron phosphate, as I mentioned, you oxidize iron to 3+, and 3+ is very benign to reactivity with the electrolytes. You don't see any surface reactivity that lead to impedance rise and degradation of performance. Now, this is good, but there is other opportunity to increase the energy and reduce the cost. And I will show you how to do that. I don't know how much time I have. Is it okay? Mr. Chairman, it's okay? Yeah. So one way of reducing the cost is to increase the energy, as I mentioned. Here is an example. If you take, for example, a pack that belongs to Nissan Leaf, for instance, is a 23 kilowatt hour, it's a 500 pounds and 125 liter. Now imagine if you increase the energy density of the chemistry inside this pack. What will happen is you can still design your 23 kilowatt hour, but your pack becomes smaller, which means the amount of cell become less and the amount of material in the cells become much less across the board, active and inactive. Not only cathode and anode, but separator, electrolyte, and so on. And you can make some significant cost reduction this way. A lot of people in the academia, at least, they refer to iron phosphate as a cheap material, and therefore the cost is low. This is very misleading because the cost of a cathode in a pack is only 10%. So if you remove completely the cathode, you reduce the cost by 10%. You don't have a battery anyway. But if you do it this way, you reduce the cost across the board. You see, we reduce the weight by almost half. And that's really cost, because these are materials, including inactive like current collectors, copper, aluminum, separator, and so on. So we really need to increase the energy. Now, I have shown you how to increase the energy of the iron phosphate by designing unique morphology. But there is also an opportunity by increasing the energy, either by increasing the capacity of the material or increasing the voltage. So fortunately, there are many other phases of phosphate that have high voltage. One of them is manganese phosphate. Manganese is still cheaper metal. As you can see here, it's a 4-volt system. So now you jump the voltage by 0.5 volt and you increase the energy significantly. And you can do the same process to make dense nanoporous type material. This is an example that shows the co-precipitation. So basically you take the precursors, mostly nitrate, which are very low cost, and then you add a phosphoric acid, and you create a chelating agent and co-precipitating agent, and you co-precipitate your material, and then you treat it with a carbon coating, and you end up with a black type powder that is carbon-coated manganese phosphate. It's very simple. As long as you control the conditions. So there is an art of parameter that need to be controlled to get to where you want. And you can see here now we have a 4.1 volt, almost 4 volt. This is basically related to the iron that get oxidized. The reason is manganese phosphate is extremely insulating. It's like an order of manganese more insulating than iron phosphate. So having a little iron does help, as you can see, if you compare the micron versus nano. And volumetrically, you can see you have almost 50% increase in the energy density. So it's still very attractive. I'm almost done. And cycling-wise, you can see the capacity is much better. This is the volumetric energy density. We gain almost 50% energy density by using this concept, and also gaining more energy by pumping the voltage higher comparing to the iron phosphate. So there is an opportunity here. And there is also cobalt. Cobalt is not very applicable in automotive, unfortunately. I didn't want to put it here because it's very low, high cost. If you add cobalt, lithium cobalt phosphate is a 5-volt system. So the energy-wise will increase significantly, but it's not very practical for automotive because of the cost of cobalt. is very, very significant, and that when you expand the production of cobalt-based phosphate, the cost will goes up, and that can defeat the purpose. But manganese is very attractive, so there is very little work has been done on manganese. There is more work to be done, and I encourage you guys to look at it, at least the people who are working on phosphate material. Now let me show you the safety of this material also. Sir, can you click on this? So this is this is a 5 amp hour manganese phosphate based cell that one student, he was crazy enough to start poking out with a nail. So I wouldn't recommend you doing it. Can you? Hello? Yeah, you can see this is very dangerous. I mean, the guy is very brave, I would say. So he's basically poking this cell, which is fully charged, highly energetic. But you can see there is some vapor because of the heat that gets generated that evaporate the electrolyte, but overall, he's very insisting. That's one of the reasons. So if we are able to design manganese phosphate that work like this, I think we'll be in good shape. I wouldn't recommend student to do this. Yeah. But he was confident. He ran all the tests and he didn't see anything. Say, okay, I'm going to abuse it myself and see what happened. Yeah. And so my conclusion to you is really, if you have to enable future electrification, we really need to develop safe and high energy system. And I've shown you at least what the community here is interested to. There are opportunities of using phosphoric acid to make very, very promising and material that is high energy through the design of the structure where we have micro-sized particle that has nanopores, where you can impregnate the electrolyte in the pores and increase the power without increasing the energy without compromising the power. I've shown an example of the iron phosphate, and also the manganese phosphate is very attractive as well. Thank you very much.
Thank you so much, Dr. Amin. So I think we'll take a few questions. We have some room. Ismail. Please introduce yourself. They will give you.
Speak up. She's coming.
Okay, thank you, Khal, for this. I have to introduce myself, okay? I am Professor Ismail Sadoun from University of Qadiyat and University Mohammed Sisfi. Thank you for your talk. I have just a small question about the manganese system. You know that manganese give very low conductivity for such phosphate. Did you measure, compare the conductivity between pure iron and pure manganese after coating, of course?
Yeah. If you don't use this process, just a normal nanotype material, I think the manganese conductivity is order of magnitude is lower than the iron phosphate, at least 10 times. Yeah, it's very, very, so you really have to go to real nano. We're talking about 50 to 100 nanometer to get some performance out of that material, yeah.
Yunus Alami. I'm from the Material Science and Engineering Department here at the university. So you have shown the benefits of using, or the benefits of using highly porous carbon-coated LFP anodes. Now you can achieve basically the same energy or power density that you can have from the conventional electrical vehicle batteries. When it comes to weight differences, I know you talked about this already, but at the end of the day, what's really the benefit of using these batteries in terms of weight? Like when you compare the two different batteries, what's the weight difference between them?
The weight.
Yes.
Okay, so for transportation, the weight is not as important as volume, as you know. So the requirement for automotive, it's always about volumetric energy density because the space is more important. So obviously, if you use a micron size, the density goes up, the weight will drop because you pack more electrode, you make your cell more compact. If you use a nano, then you have to put more cells and the weight goes up. And yeah, so that's the issue. But the consideration is always about volumetric. Then, yeah. So, but we address that because of the density, as I mentioned. So,
Okay.
you know, if you look at the weight of the iron phosphate, if you have like, let's say 23 kilowatt hour, it's going to be heavier than an oxide, obviously, because the oxide has much more energy. But with this approach, it will not be as heavier as if you have nanomaterial. Yeah.
Okay, thank you.
There's one right there. Can you
Thank
speak
you.
up?
Thank you for nice talk. I am Uzawit Khalid from Managem Holding, and my question is about how to enhance safety of materials. You have shown that the way that permits to reduce the cost, but what about safety?
About the safety.
Yes.
Yeah. Well, as I mentioned, if you really want to make a safe material, cathode play a big role. The safety is the whole system. You know, you start with the decomposition of the SEI or the anode that generates some heat that basically accelerate the decomposition of the cathode. Then the energy out of the cathode is very high, as you know. And it's mostly related to oxygen release from the cathode during the decomposition that react with the electrolyte. Now, the best way to address that is to find a material that does not generate oxygen. And the phosphate, obviously, if you look at if you run an X-ray before and after, you have only change in the structure. It says FAPO4, but its oxygen release is almost zero. And that's the best way of enhancing the safety. Or you can have electrolyte that does not oxidize. That's another way.
Okay, so thank you, Amin, for your good presentation. So I have one question about cobalt. You say that cobalt, it's not recommended to use it in the this. Okay. So I am Hakim Fakir from Managem Group, Reminex Research Center. So as you say that the cathode represent only 10% of the global price of lithium iron. That means that if we add, for example, let's say 5% of cobalt in the lithium iron phosphate cathode, we can improve the capacity or the cycle life of this material. How do you think about that?
Yeah, so the cost is based on mostly nickel or manganese based. Now, if you have 5% or 10% cobalt, in the case of cobalt phosphate, it will be more, obviously. And if you have a major penetration of electric vehicle, that amount of cobalt needed will be very large. It's not in consumer electronic. We're talking about like 1 million vehicle is equal to the amount of materials in what has been done in consumer electronics so far, just 1 million vehicle. So imagine if you have 20 million vehicle, the cost of cobalt will increase significantly because the demand on that cobalt will be much higher than what we need now, at least 20 times much higher. So that will be a serious issue. The Department of Energy and the auto industry had decided not to use dominant cobalt-based cathode material for the reason I explained now.
Okay, thank you.
Yeah.
Thank you. So,
here, Hasna Azia, PhD student here at the university. It's a pleasure to see you. Thank you for your presentation. I have a question about the propylene coating. It wasn't mentioned in the slide. Is there any thermal treatment after that?
Yeah, so basically you crack it around maybe 300 degrees C, and once you crack it, you have carbon there. You don't have to go higher because you're going to evaporate your carbon if you go higher in temperature in form of CO2. So you have to be careful about the cracking temperature.
And how long? 300 and how long?
Yeah, it's
time?
very quick. It doesn't have to be more than an hour. You just need a fluidized bed, for instance, because you want to circulate your powder to make sure that the accessibility of the surfaces are there, and it should be okay.
Okay, thank you very much.
Yeah.
My friend here has a question. Can I pass the micro? Just one small
Good to have a question from students.
Yeah, so thank you, Mr. Khalil, for this nice talk. Just I'm Ilham Beza, also PhD doctor now, from Ismail's group. I want to ask you about the manganese iron phosphate, because we use it in our group, and we saw that the manganese, it's not completely activated. So just I'm asking if you compare, or if you measure this activation in your system.
Yeah, so, obviously, as I saw in the figure, we activate about almost 85%. It really depends on the way you coat your material and the weighting of the electrolyte in the powder and the process of making the material.
Okay.
So it is true, it is very, very insulating. As I mentioned, Ismail has asked the question, it's 10 times more insulating than iron phosphate. So depending on the process, the coating, as I mentioned, because you have to make sure that not only the surface of the particle is coated, but also inside the pores, where a lot of active, because they are accessing to the electrolyte, so you have more activity inside the pore. So if you don't have that, it will be difficult to activate all of the, to get most of the capacity.
Okay, thank you.
Okay, thank you. Okay, so our next speaker is Dr. Mamu Tikalim. Where is he? Dr. Tikalim? Okay, so Dr. Tikalim will be talking about exploiting the potential role of fertilizers in increasing food production. Dr. Tikalim is a professor of soil and science and currently head of Center for Soil and Fertilizers Research in Africa within the University Mohammed VI Polytechnic in Ben Guerir. Before, he was a senior director of the Ethiopian Agricultural Transformation Agency, where he launched and led the Ethiopia Digital Soil Fertility Mapping and Fertilizer Blending Project. He served as the State Minister of Agriculture, Vice President of Haramaya University, Senior Researcher and Director of Research and Founding Fellow of the Ethiopian Academy of Science. He is the founder and first editor-in-chief of the Ethiopian Journal of Natural Resources and founding fellow of the Ethiopian Academy of Science. He is the recipient of 2014 African Green Revolution Laureate, Award 215 UN FAO International Global Ambassador for Soils nomination, 2016 International Norman Borlaug Laureate Prize, given by the International Fertilizer Industry Association, Certificate of Recognition and Gold Medal Award for Meritorious Achievement in Agricultural Research, Swiss TOS Disciplinary Award, and recognition by the Internal Potash Institute. He has published extensively and served in several international scientific committees. Dr. Tekalim, you have the floor.
Thank you, Mr. Chairman. Do I need this? Yeah. Thank you. So my presentation, as the chairman said, is about a different subject than what Dr. Khalil Amin presented, which is also close to us. It's about food security, soil health, fertilizers, and so on. I'm the one actually running. How do you operate it? Where is he? Come in. Oh, yeah. Okay. So this will be the outline of my talk. I mean, just to take you through. We'll see what the world food security status is, especially the sub-Saharan Africa, what are actually the main causes for land degradation, and we'll also see some of experiences that we passed through in Ethiopia and what we are trying to do for Africa. If you see, in the world today, at global level, there is enough food for all. But the problem is the geographies do not match. Where the food is produced and the food is required never match. Therefore, about 800 million people go hungry every day to bed, while at the same time, equal amount of people go for medication because they overconsume. And at the same time, about 30% of the food we produce is lost through post-harvest loss. And about 1/3 of the food produced is also wasted. This is the scenario we are in. If you see, from the past 2.5 decades and so on, food insecurity is actually steadily decreasing. It was 1 billion like like 2.5 decades ago. Now, like just 2 years ago, it was about 800 plus, which is good news. So if we actually do further than this, the food insecurity gap can further decrease. But when it comes to sub-Saharan Africa, the situation is different. Although globally food insecurity is decreasing, you can see that South Asia and in sub-Saharan Africa, food insecurity is increasing. This is actually FAO data just taken 2 years ago, compiled, and you can see that the situation is not improving in these two regions. Look at East Asia, it is shrinking dramatically. So maybe we are taking over what is actually left from there. And there are many contributing factors. If this is actually the global land degradation status, you can see that Africa, developing countries, the soil status is highly degraded, meaning every time the nutrient is being lost. And the degradation is in various forms. It could be upslope cultivation, big rivers taking away all the fertile soil and nutrients, gullies and waterways, gullies converting to waterways. Through this, we can see that the amount of nitrogen and phosphorus lost is equal to the amount of NP fertilizers that sub-Saharan Africa uses annually. And most of the runoff, even up to 50%, is not retained in the soil. It's lost. All these contribute to land degradation. And then extreme soil acidity and soil salinity. Actually, this is the worst situation in developing countries. And even crop removal in one way or another from the field. It could be the stover, it could be the hay, it could be the cow dung, all are removed. And what is left in the soil? God knows. There is nothing. So what we can see is complete imbalance in terms of nutrient reserve in the soil. And this is not very encouraging at all. And waterlogging, again, another problem on high clay soils. This is also one means of lower productivity. Nutrients are lost through volatilization and so on. At the same time, even the good soils are not being used for a long time. And the impact is, as you can see, severe nutrient depletion. This is very common in sub-Saharan Africa. And just because of the severe nutrient depletion, if you just check where is the least crop productivity in the world, again, it is sub-Saharan Africa. I don't know how we can manage to take this. Again, the other scenario is, look at the population. In sub-Saharan Africa, the population is increasing dramatically against what the situation is in terms of productivity, land productivity, crop productivity. The other scenario is, globally, cereal growth rate is decreasing tremendously. Actually, it is going further in all crops, wheat, maize, rice, and so on. So the growth rate is actually diminishing. This has a good reason. If you see, even the growth rate, it's not very common in developed countries. The lower, actually, in the chart, the green one, developed countries, there is no more that they do in terms of land expansion or reaching the maximum productivity. They have already reached there. So why need? So the little increase in production is from developing countries. And unfortunately, that has been through land expansion. I don't know how long that will take us, but this is the reality. In terms of fertilizer use, I'm sorry, the legend on this side is just actually near to the graph, but it has nothing to do, actually. It should be taken away. If you see nutrient use, fertilizer use, poor Africa only consumes 3% of the global fertilizer consumption. I mean, realize the poor nutrient status, the poor productivity, the rising demand in population, but you can see that it's only 3%. East Asia and the rest are actually tremendously increasing their fertilizer consumption. The hard reality is that many policymakers, even researchers fail is just by improving crop varieties, we think yield can increase. No way. This is actually a slide that I shared from Professor Osuko from Japan. He's a famous economist. He did work in West Africa, and he found that if the traditional varieties are just fertilized, then their immediate nutrient response will collapse. If they are in the modern varieties, then the middle will happen. That's it. With proper fertilizers and so on, the modern varieties or the improved varieties will be actually the middle curve. But customize the fertilizer, maintain good soil health, proper agronomic practice, actually it is that the last curve that you will see. This is actually the reality that we should all appreciate and understand. Now, just because we don't give more emphasis to soils and just because the fertilizer is also a free commodity. In most African countries, fertilizer you can pick from anywhere. So farmers knowingly or unknowingly might use the right fertilizer or the wrong fertilizer. They are not customized. So since the fertilizers they use do not actually satisfy what their soils are lacking, fully satisfy, the yield they get is minimal. And immediately, farmers will resist using fertilizers. This is the situation in Africa, in all developing countries, even in Ethiopia. Until recently, farmers who resist to use fertilizers, they are just considered as bottlenecks, and harsh measures were taken against them. But the poor farmers were correct. Even if myself, I were a farmer, why should I buy the fertilizer that gives me the least return? And many scientists or researchers conclude farmers are resisting to use fertilizers because they are expensive. They are costly. Is that so? We have disproved it now in Ethiopia. It's not because of that. It's because even if they use it, the yield increment is very minimal. And the other serious gap is take the globe, regionally, nationally, globally, many commodities, be it wheat, be it maize, be it potato, be it rice, all of them have global centers. All of them have global centers. When it comes to soil, who cares about soil? Soil, the outside, actually, when you walk outside, the soil you step in, nobody cares. But the hard reality is 95% of the food we consume comes from the soil. This is actually the problem. And we cannot continue like this. We cannot continue with this vicious circle. Because for now, it might mean a lot of people migrating. But who knows the future? If this might not incite armed struggle. When there is no food, hungry stomach cannot keep quiet. So we have to do something. Look at this scenario. I have said, in actually Africa, the population is increasing. But when we see the food demand by 2050, just 3.5 decades later, you can see that the food demand in sub-Saharan Africa is a big, actually, it should be like about 160% of the current demand. But look at China, look at India, it's by far better. Although they are the most populous, maybe they are using better technologies and they are producing better. The situation is not increasing in sub-Saharan Africa. This is actually a slide produced as a policy document, a slide taken from a policy document that when I served as Global Climate Change Commissioner, we published a policy document, and I took it from there. If you see the straight line, the straight curve is the food demand. Food demand will never go down. So it's actually a straight curve. But where is the current scenario? Business as usual, the food that we are producing is going down like this, the red line. Now, if we manage to reduce post-harvest loss, then we might a bit shift it to the yellow line, which is almost a straight line. But still there is a big gap between the demand and the yellow line. So, if many policy measures are taken, fertilizers are customized, soil health is maintained, all agronomic practices are used, then we can actually see that green line, which is almost very near to the first black line. Meaning there is still a food gap between demand and supply. And this is actually if you take a lot of measures. So is there a possibility that the food gap will be reduced? There is one way which is difficult. And the only way is if we stop food wastage that's mostly happening in developed countries. And if we also change the diet from fat, meat, and so on to vegetables, healthy diet, which is also difficult to do. But this is the reality that we are in. Take also the impact of climate change. Climate change is actually worsening our situation. Added to all what I mentioned, climate change during the past 2 years has actually affected the food security situation of more than 20 million people in Africa. And all are now on food handouts. Countries are trying to ask for aid, donation, like my country is also spending a lot of money in buying food. So the future is a bit complicated as well. Let me take you to the country I know most, where I worked for over 3 decades, nearly 3 decades, because this is where I can only also cite. In Ethiopia, for the past 2.5 decades, we have tried to address all issues. For example, the community-based participatory watershed management to rehabilitate degraded lands. So far, we have rehabilitated more than 20 million hectares of previously degraded land. And also, we have tried to improve the productivity of those waterlogged vertisols. They are the 4th soil order in the country in terms of coverage. And we have developed very good technology where farmers can employ and produce more and maybe frequently as well. Maybe no time to discuss that. And then the other is, like back in 2006, we have launched the National Acid Soil Rehabilitation Program, which is showing good progress. And then there has also been a big campaign to scale up the use of organic sources such as compost. But all this might have helped. But in terms of crop productivity, nowhere. Still nowhere. And that actually led us to think again. Just actually 5 years ago, this was the scenario. You can see that the crop actually productivity rate was increasing, especially for maize, wheat, barley. For the rest, it was not that attractive. And for the past 2 decades also, there has been annual growth in terms of agriculture. But the only time, like a year ago, the average cereal productivity was 2.23 metric tons per hectare. So we cannot boast about this. We had to rethink. We had to actually Oh, I'm sorry. Okay, yeah, I will be there. And therefore, what we started, well, fertilizer use has been increasing. This is actually the era of fertilizer in terms of fertilized. And fertilizer use has been increasing, but when it comes to fertilizer application per hectare, still that of Ethiopia is lower. The reason is we have about 13 million hectares of land cultivated. Although our volume of fertilizer consumption has been increasing, divide that by the amount of land, it's always lower than other countries. So what Ethiopia decided is, back in 2012, a strategy was developed to conduct digital soil fertility mapping in the country. We consulted many stakeholders, fertilizer companies, including OCP, others, who donated lots of fertilizers. And we now currently, actually this is not even current, we can say that at the moment we have surveyed close to 700 districts, and we are only left with 20 districts to finish. And we have customized our fertilizers for them all areas and produce these atlases. They are not countrywide atlas. These are regional atlases. We have 9 regions and 1 city administration. By December 2017, we would have produced all regional atlases and 1 big end-to-end report. And where are we? For example, this is one particular district. The fertilizers have been customized even by sub-district. Although when you do actually the predictions, even those small parcels need different kinds of fertilizers. Then we have to put a threshold where any parcel or any area that's less than 10 by 10 kilometers will be shifted approximately to the next best fertilizer. And this is actually what we are practicing now. Otherwise, like 6 decades ago, Ethiopia started using DAP and urea. And until 2012, Ethiopia was using only those 2 fertilizers. And now, actually, the situation is different. And these are actually the types of fertilizers that are now in our shopping list. And what we discovered, bitter fact, is that sulfur deficiency in Ethiopian soils covers about 95%. And I was actually discussing with OCP Africa agronomist Sise that he also showed me for the work they did in Nigeria, the fertilizer recommendation was exactly similar to one of our actually recommendations, NPS zinc boron. So this is the reality. And we have also established fertilizer blending plants. While we did the survey, we also introduced new fertilizers. New fertilizers donated mostly by OCP, thanks to OCP. We didn't buy, even they were shipped to Ethiopia. And look at this result. So 13 million farmers, they didn't actually waste any time when they saw such comparison. This is a previously planted maize with DAP and urea. The same maize planted 15 days later, actually, when we went there 8 weeks ago, it was a different story. And farmers visit this, and they say, bring the fertilizer. Now we know what type of fertilizer is important for us. The same story here. I mean, it's very successful stories. And nowadays, it's very common to see a productive maize plant with 4 fertile and good crops. And this is actually the result of customized fertilizer. Now, this is an experience that we did in Africa. OCP Africa has also done very good activities in many African countries, like on rice belt, cacao belt, and so on. But we need something for sub-Saharan Africa. So we came up with the Center for Fertilizer, Soil and Fertilizer Research in Africa, here in the university, that we launched last January, and that I'm currently heading. This is no more business. This is actually doing the right thing for Africa. And we have developed our strategy. Our main mission is to support African countries so that they could replenish their depleting soil fertility through using customized fertilizers and increase their agricultural productivity. And we have, for the next 5 years, we have also itemized what kind of work we'll do, like digital soil fertility mapping, and then actually also together with OCP Africa, evaluating also these new fertilizers, introducing to farmers. And then we collect lots of soil samples, we analyze them, and we also do fertilizer recommendations, pertinent customized fertilizers, and we also produce those atlases that you saw for Ethiopia, also for sub-Saharan African countries. We cannot do them alone, but we are trying. And in order to accomplish this, we'll also establish a very modern soil fertilizer and plant analysis laboratory that will cater entirely for Africa, and also upgrade the African experts engaged in that area through connections, sample exchange, and so on. And our major strategy is we'll never go there and do it on our own. No, no. What we'll do is we will engage local students, graduate students, to actually own the work. We support them, they do it, and then they can also advocate for it at the end. This is also what we did in Ethiopia. The 5-year research program, the flagship research program, is actually Africa Customized Fertilizer Initiative. So we have the digital soil fertility mapping that we hope to conduct in 4 countries, and then research on soil micronutrients and human health, and that we will like to do in Morocco and 2 other countries. Phosphogypsum research in Morocco and Ethiopia. The reason is phosphogypsum cannot be transported, but in Ethiopia, OCP is also launching a big fertilizer complex. So here also it has, so we can see how phosphogypsum can be used to reclaim salt-affected soils, now that the threshold level has come down. And then the research capacity building is actually what we'll do in terms of establishing the laboratory, the soil archive, sample exchange program, and so on and so on. So these are actually our target countries, about 16 countries, mostly also those where OCP in Africa is targeting. Now, as I said, we have started this, but we need partners who will actually work with us so that at the end of the day, we can increase the fertility status of African soils, customize the fertilizers that these countries use, and then increase production productivity. And we also contribute toward the soil fertility replenishment in Africa. Thank you very much. Did I take time?
Yeah, that's fine. I think we have room for one question. Okay, go ahead, please.
Thank you, Professor. I'm Dr. Sise from OCP Africa. I would like to thank you for your good presentation or for raising very important issue about soil health. I would like to make two contributions. You stress nutrient depletion by erosion, but many parts of Africa, we have other phenomena which are not water erosion. You have desertification, you have wind erosion. We are also addressing a large part of cropland in Africa. We need also to address this. The second contribution is fertilizer is surely one wheel we need to develop in order to customize it and to improve yield. But another component is water management. If in Asia they are growing more food, it is at least 40% of their land are water managed properly. In Africa, it's less than 10%. Even if you have good fertilizer and you don't manage water, if 80% of rain-fed agriculture will hardly meet the increased food that we are expecting. So I would like to add fertilizer, yes, water management should be added in order to improve our production. We should not forget about this component when we talk about Africa production. Thank you very much.
Thank you. I think I take it also as a positive comment. Well, without water, nothing happens, you are right. But there is also a water component there. But due to limited time, I didn't go through all that. Thank you.
Okay. So on behalf of the organizers and participants, I would like to thank our two speakers. Thank you. Okay. Okay, so we close the session.
SYMPHOS, tout d'abord, c'est un symposium international sur l'innovation autour de l'industrie des phosphates. C'est l'un des plus importants, les plus grands symposiums au monde aujourd'hui dans ce domaine. Cette quatrième édition donc, fait suite à 3 précédentes éditions qui ont permis un petit peu de développer un certain nombre de partenariats dans le domaine scientifique et l'innovation autour du phosphate. Cette année, la nouveauté, c'est qu'on l'organise dans une prestigieuse université, c'est l'université Mohamed VI Polytechnique de Ben Guerir. Nous avons accueilli aussi dans les 105 exposants à travers le monde. Ils viennent des États-Unis, ils viennent de la Chine, ils viennent de Singapour, ils viennent de différents endroits du monde pour promouvoir leurs produits, leur savoir-faire et partager ce savoir avec le monde industriel, le monde scientifique. L'objectif, c'est donc, comme j'ai dit, une agriculture durable pour le bien du monde.
When I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what you are putting bricks to build a future. And I think it's really fascinating, and I believe the rest of the world would need to know more about it. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me. And I learned it today, and I feel very happy, and I'm glad to be part of it.
We're about to enter the second plenary session, which is going to be presented by Professor Bruce Rittman of Arizona State University. He's a professor of environment engineering, and he will talk about, well, quite appropriately, about biotech and its role in making the phosphate industry more sustainable in the future. Also, of course, don't forget to ask all your questions in the comments or on Twitter using the hashtag SYMPHOSLive. Tune in to our live feed on YouTube and on LinkedIn. And also, don't forget to tweet at us if you have any questions, any remarks, anything you want to share with us. Use hashtag SYMPHOSLive. Hashtag SYMPHOSLive. Thanks a lot for following, and we see you tomorrow. Thank you.
وانتهت. Yes.
%, goes to 90%, and in this case, so it 2 million tons, you produce another 100,000 tons, and the market value at 70 BPL is $98 a ton. So in this case, you're saying, hey, that $100,000 in added tons is worth 9.8 million bucks, or roughly, 1% recovery is worth about $2 million. So what I'd like to cover in this slide is some rules that would help the extraction process and the beneficiation process work better. And so the first one, you want to avoid ore dilution. Keep the feed clean of overburden and other contamination. You want to liberate the feed as needed, but create as few fines as possible. And then in the next step, you want to wash the ore well, remove the clays and other contaminants. Then you also want to size the feed well for the flotation sections or other equipment. And then what you want to do is you want to float similar feeds, size feeds together. And then you want to use the cleanest water that you have available for conditioning and then for flotation. You want to condition the feed at the right solids and at the right pH. And then this is a pet peeve of mine. A lot of times you will see conditioning that's split between two float cells. And a lot of times you'll see one float machine working well and the other one's not working well, and it's because the load's not balanced. You want to use the right amount and type of reagents, water and the air, and specifically the right bubble size. And you want to employ smooth, non-turbulent flotation at the froth zone. Moves from the pulp into the froth zone for collection. And then also, I think you should feed the plant at stable rates and do not overload the equipment. Now these are basic, these are fundamentals that I was talking about, but it's like the Nike ad. You just need to do it. Moving on to the next part is the phosphoric acid role for better digestion, filtration, and evaporation, and how fertilizer process aids will help you overcome in the gypsum crystal formation and speed filtration and reduce acid losses. Defoamers reduce foam and entrain gases in the digester and the evaporator to improve efficiency and increase throughput. So better rock quality combined with these process aids, reduces your production costs and improves overall operational efficiency. And then lastly, process aids can solve specific issues, sometimes at a lower cost than a capital investment or a capital improvement would. So in this case, this is an example of the value of a filter aid. In this model, you're saying, hey, market price of DAP is this. A typical DAP plant would produce 1.8 million tons. And as you move across, the raw material cost, the fixed cost, the variable cost, creates a total spend versus the sales revenue, revenue less spend creates a margin. And as you move down for the improvement case, with filtration aid, you can get 10% increased production. And so you can say, hey, we make 1.98 million tons, and you can see how it rolls across. But the main factor here is you can see, the margin, how your margin improves, and you get, this is the value of the filtration aid. So you can see how it brings a lot of value in DAP production. And in the second case, you can say, gosh, if you can get 20% more filtration capacity, the value of the filtration aid goes up significantly. And so in this is a case where would be where the filtration is the bottleneck to the process. So our fertilizer vision, trying to create, what better crop nutrition looks like, and our goal is to help fertilizer companies, produce better fertilizer, increase, crop yields in a manner that safeguards the environment. So fertilizer production, we want to make the strongest, most uniform size granule while meeting the grade and analytical requirements. And so here you can see, defoamers improve the granulation operational efficiency. Granulation size and solubility and hardness, consistency, and diversity are largely controlled by the phosphoric acid and their characteristics. So that ties back to better rock, better phos acid, why that's so important. But then also granulation and coloring aids can help mitigate acid impurities by improving granule hardness, roundness, color, and appearance. So in these fertilizer granules treated with the appropriate dust control and anti-caking coatings, they're easier to handle, easier to store, easier to ship. And then the regulatory requirements, such as REACH, they vary around the globe and require careful consideration of the raw materials used in fertilizer. So in my next example, we're going to describe how magnesium reduction benefits the DAP process. And you can remove magnesium many ways, but you would say in the beneficiation process, if you can get the magnesium out, there's a big value, which we'll show here in this model. So you say the base case, you're seeing a typical DAP complex has a load of about 1.5 MgO. And so you can, through improvement, by reducing, going from 1.5 to 1%, you will see an 8% increase in the production. And this model is, just like the filtration aid model, but you can see the value of lower MgO is significant. And so you can see how the mine and the phos acid plant and the DAP plant tie together. And these numbers, just for reference, I was using sulfur at 75, rock at 98, and ammonia at 340. So that's how that feeds into the model. So the micronutrient and the blending process, the goal is to add micronutrients so that the phosphate fertilizer meets the specific nutrient needs for varying soils and varying markets. So the micronutrient incorporation may complicate the granulation process, create a softer and irregular granule. And segregation can occur due to difference in the particle size, the volume, the density, and the shape. And so fertilizer process, the additives and the granulation aids and custom coating agents, they provide dust control, anti-caking and prevents pile set, which can be dangerous, fortifies the softer granule, and allows for improved handling and shipping. Okay, yes, thank you, good. I think we're doing well on time. So to wrap this all together, this rendering, I have created a vision of how important it is to mine and to beneficiate and to think as a fertilizer producer how these different pieces fit together, and how that the fertilizer process aids and mining chemicals create value, and that when you tie them all together, at the end of the day, the fertilizer producers benefit and the farmers benefit. So thank you for your time. This concludes my presentation. I'm open for a few minutes of questions. If there are no questions, I have some more slides. Well, we can. How much more time do I have?
5 minutes.
5 minutes. Okay. Well, if there are no questions, I've prepared a few slides about RMAS. And so RMAS, we're always striving for better and what better looks like. And so we've been creating, innovative solutions, around the world. We're founded in 1967, and as a note, we're celebrating our 50th anniversary this year. We're, a global leader in specialty chemicals for mining and fertilizer and phosphate, asphalt and oil gas industries around the globe. We're headquartered in Mulberry, Florida, but we are a global company, and you'll see in the next slide where we're located. We have over 400 employees and customers in 7 countries, and our owner is Golden Gate Capital. And so you can see here where we're located. And the theme here is really wherever there is a major phosphate deposit or production point, that's where we are. And so we think globally, but we act and serve locally. And then so these are the markets in which we serve, and you can quickly scan through them. And these are, we serve some of the largest producers around the world. And this is truly the end. So thank you for your time.
Okay, it's an honor for me to introduce Mr. Alexej Mikhailovsky. I will speak. Okay. Mr. Alexej is responsible for technical service of BASF Mining Solutions business in Europe, Middle East, and Africa. He has a very large background in chemistry. He will share with us BASF effort to help the industries to improve flotation plant performance by the precise control of the HLB value. I'll let the audience to discover what is the HLB. Thank you very much. You have 20 minutes for the presentation and 5 minutes for the session.
Thank you very much for your interest. I'd like to present our recent effort in improving the flotation plant performance or flotation process performance in general by using precise control of hydrophilic-lipophilic balance of the additives that you're using to modify the standard fatty acid collectors. The situation on the ground in the phosphate industry or in general is well known. I'm not going to repeat thank you. I'm not going to repeat many of what my predecessors said. The easy ore is gone or is being depleted. more difficult deposits require more and more advanced beneficiation techniques. The typical process that is
SYMPHOS, tout d'abord, c'est un symposium international sur l'innovation autour de l'industrie des phosphates. C'est l'un des plus importants, les plus grands symposiums au monde aujourd'hui dans ce domaine. Cette 4e édition donc, fait suite à 3 précédentes éditions qui ont permis un petit peu de développer un certain nombre de partenariats dans le domaine scientifique et l'innovation autour du phosphate. Cette année, la nouveauté, c'est qu'on l'organise dans une prestigieuse université, c'est l'université Mohamed VI Polytechnique de Ben Guerir. Nous avons accueilli aussi dans les 105 exposants à travers le monde. Ils viennent des États-Unis, ils viennent de la Chine, ils viennent de Singapour, ils viennent de différents endroits du monde pour promouvoir leurs produits, leur savoir-faire et partager ce savoir avec le monde industriel, le monde scientifique. L'objectif, c'est donc, comme j'ai dit, une agriculture durable pour le bien du monde.
When I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what your putting bricks to build a future. And I think it's really fascinating. And I believe the rest of the world would need to know more about it. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me. And I learned it today, and I feel very happy, and I'm glad to be part of it.
We're about to enter the second plenary session, which is going to be presented by Professor Bruce Rittman of Arizona State University. He's a professor of environment engineering, and he will talk about, well, quite appropriately, about biotech and its role in making the phosphate industry more sustainable in the future. Also, of course, don't forget to ask all your questions in the comments or on Twitter using the hashtag SYMPHOSLive.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
En donnant en 2012 le coup d'envoi de la construction de l'Université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohamed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore l'Aïoun. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur-manager, futur ingénieur-manager de se retrouver mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohamed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
The world is changing, populations are growing, and by 2050 there will be another 2.4 billion mouths to feed. So if we can do more to help more farmers grow more food more sustainably on all types of soil, we'll be contributing to a better future for all. As a global leader, we at OCP believe that working together is the key to ensure a sustainable and prosperous agriculture. We push the limits of science and technology for sustainable agriculture, not only for us, but for future generations. Using our expertise to transform Morocco's precious resource, phosphate, the work we do is of vital importance, constantly looking to create innovative fertilizer solutions
Hello, we're live here from SYMPHOS 2017, and we're with Mr. Benoît Magny from France, and we're just gonna ask him a couple of questions about what he thought about this morning plenary sessions. So, Mr. Benoît Magny, what did you expect first from this SYMPHOS, and are you satisfied with how it's going and this beautiful campus that we have here?
Yes, it's really a very impressive campus, and I was very impressed by this new university. And it's the first time I attend this SYMPHOS meeting, and it's a pleasure to meet all these people related to phosphate industry and to meet people from UCP as well. So as far as now, I'm very satisfied with the Congress.
Thank you very much. And about this first plenary session that we had this morning about automotive technology, it was a bit surprising to hear about that here in SYMPHOS. What do you think? What do you think about the importance of this kind of research? And is it really important for our industry to get involved in all types of technological research?
I think it's very important to find new development for phosphate derivative, and this one with battery is a very interesting one, and I think it's very promising. I'm not in this business at all, but I think that it's a promising business and opportunity for new phosphate derivatives.
Okay. Thank you very much, Mr. We'll set you free for now. Have a great day.
Thank you.
Thank you. Hi, we're at SYMPHOS 2017. It's our second day here. We're with Madame Evelyne Lequien from France, and we're just gonna ask her a couple of questions about how she feels about this second day at SYMPHOS, and what she thought about this second plenary about food security and the use of fertilizers in this fight for food security and against climate change.
Alors, je peux parler en français?
Bien sûr.
Moi, déjà, je suis venue ici parce que je représente les éditions techniques de l'ingénieur, c'est-à-dire une énorme base documentaire qui a été réalisée à l'attention des étudiants dans les écoles d'ingénieurs, sur tous les secteurs de l'ingénierie. Donc du coup, je suis surtout venue pour rencontrer les gens de l'OCP et savoir ensuite comment effectivement leur proposer cette base documentaire qui est un espèce d'énorme Google hyper bien documenté d'une part et puis continuellement alimenté d'ailleurs par des chercheurs ou par des gens que j'ai retrouvés ici sur les entreprises. C'est souvent, ce sont des expériences d'entreprises qui deviennent... Voilà. Ensuite, j'ai du mal dans les conférences à identifier effectivement les gens. J'ai aimé la première conférence avec ce monsieur indien, désolé,
professeur Ramakrishna,
qui est un type un peu showbiz et tout, et donc qui est très engageant. Donc là, on tombe sur des gens comme ça qui vous parlent effectivement des problématiques de l'avenir d'une façon intéressante. En plus, il vendait Singapour. Je connais Singapour, je vois bien, oui, ce que c'est devenu. Quant à la conférence tout à l'heure, là, ce monsieur éthiopien, oui, j'ai compris qu'il se bagarrait pour trouver des méthodes de fertilisation qui soient en adéquation avec ces terres, qui sont, je connais un peu l'Afrique, qui sont hyper arides, hyper compliquées. Enfin, oui, dès qu'il pleut dessus, tout fout le camp. Enfin bon, et puis surtout avec des gens qui ne sont pas du tout formés. Et la problématique, c'est pas la terre, parce qu'on a réussi à cultiver partout dans le monde, mais c'est la formation des gens. Et c'est ce qu'il finit par demander. Alors après, il finit par demander du partenariat, de l'argent, tout ça. Je vois bien la démarche. Voilà. Oui. Donc ça, Mais en même temps, c'est intéressant de voir que ce sont ces types-là qui prennent en main le sujet, et plus justement l'Europe qui se mêle de ce qui la regarde pas.
Oui, mais effectivement, comme vous dites, l'argent, c'est le nerf de la guerre. C'est le nerf de la guerre et il faut bien l'utiliser. Justement, comme ici, on a ce gros investissement dans l'éducation. Et effectivement, pour ce qui est de l'Afrique, par exemple, vous devez être au courant, l'OCP crée une carte de fertilité des sols pour plusieurs pays en Afrique, ce qui elle est déjà établi pour le Maroc.
Je ne savais pas qu'ils faisaient ça avec beaucoup de précision. Par contre, moi je travaille avec le Maroc, j'ai mis une société ici. Et c'est vrai que du coup, je suis cette évolution. Et je trouve vraiment super que le Maroc ait pris effectivement le leadership sur l'Afrique, en formation, en tout d'ailleurs, en tout. Nous, on aurait dû faire ça depuis très longtemps, on ne l'a pas fait. Bon. Mais c'est vrai que quand on voit des équipements comme ici, qui sont certainement faits pour les Marocains, mais certainement pour beaucoup, beaucoup d'étudiants africains qui vont venir, c'est pour ça qu'ils font des campus partout. J'ai eu la chance de visiter quasiment toutes les universités, là, les nouvelles sorties au Maroc, et c'est vrai que c'est des campus magnifiques pour tout le continent. Donc, bon. Mais ce qui est intéressant, à chaque fois qu'on vient ici, c'est cette espèce d'énergie, d'engagement que l'OCP prend. Et du coup, ça effectivement déroule derrière des tas de gens qui arrivent. Moi, je rencontre les gens dans le bus ou ailleurs, enfin, même dans les trucs. Bon, il y a des Chinois, il y a des Indiens, il y a toute une délégation russe qui est là. Et finalement, c'est eux qui commencent à...
C'est bien qu'on puisse avoir de l'optimisme voilà, pour ces chantiers qui sont quand même assez difficiles, assez challenging pour l'avenir.
Enfin, voilà ce que je peux en dire. Hein. Mais en plus, je suis vraiment... je fais du commercial en fait dans ça. Moi, hein. Donc je ne suis pas une spécialiste en...
Nous non plus.
Il y a des tas de trucs, je ne comprends rien, mais en même temps, je comprends tout parce que, bon, derrière les mots, on comprend
exactement.
l'innovation qui arrive. Exactement. Voilà tout ce que je vous dis. En tout cas, c'est un lieu magnifique. Sur un plan architectural, moi j'adore. Voilà. C'est aussi important. Et puis bon, c'est toujours superbement bien organisé, ce que fait l'OCP, ce que font les événements au Maroc en général.
Beaucoup.
Voilà.
Merci beaucoup, madame. Bonne journée et bonne suite au SYMPHOS. Au revoir. So, let me just translate this. It was a bit of a long talk with Madame Evelyn here. She told us that she came here mainly to sell a big data solution she has for engineering students, but she also told us about how really investment and proper use of resources and financial resources throughout investments in education and in fertilization can really help us to be up to the challenge of food security and how to cope with climate change in the future. We'll move. Hey guys, we're back. It's been a very exciting morning we're having here, and 2 plenaries, 2 workshops. We learned about a lot about food security and climate change, about automotive battery innovation, although that's a bit surprising for a phosphate industry event, but that's how innovation works. Fundamental research into materials and conductivity, phosphate processing, hydrocycloning technology, and well, once again, we're getting ever closer to understanding how really important innovation is for absolutely every one of the 7 billion people that live on Earth. And now we're off to our lunch break, and we're gonna leave you to watch again, if you wish, the first plenary that was given by Professor Ramakrishna yesterday morning. And it's a very interesting talk. If you've missed it, do not miss the opportunity to watch it today, and do not hesitate to comment about it and talk about it using #SymphosLive, #SymphosLive. We'll be back in about 45 minutes, so stay tuned, and we'll see you and we'll tell you what's going on this afternoon. See you. Thanks a lot.
donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur-manager, futur ingénieur-manager, de se retrouver, mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
The world is changing, populations are growing, and by 2050 there will be another 2.4 billion mouths to feed. So if we can do more to help more farmers grow more food, more sustainably, on all types of soil, we'll be contributing to a better future for all. As a global leader, we at OCP believe that working together is the key to ensure a sustainable and prosperous agriculture. We push the limits of science and technology for sustainable agriculture, not only for us, but for future generations. Using our expertise to transform Morocco's precious resource, phosphate, the work we do is of vital importance, constantly looking to create innovative fertilizer solutions across the whole value chain. Mining, refining, transforming, and creating products for the benefit of people worldwide. Phosphates are vital to the development and growth of crops, and so the fertilizers created from phosphates are of growing importance to global farmers, where strong root growth has become an ever more critical factor. That's why we don't just mine better and smarter, or even refine our production techniques to produce better performing fertilizers over a wider range of soils. We also mine new ideas, refine them, and then spread them to all four corners of the globe.
currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
The world is changing, populations are growing, and by 2050 there'll be another 2.4 billion mouths to feed. So if we can do more to help more farmers grow more food more sustainably on all types of soil, we'll be contributing to a better future for all. As a global leader, we at OCP believe that working together is the key to ensure a sustainable and prosperous agriculture. We push the limits of science and technology for sustainable agriculture, not only for us, but for future generations. Using our expertise to transform Morocco's precious resource, phosphate, the work we do is of vital importance, constantly looking to create innovative fertilizer solutions across the whole value chain. Mining, refining, transforming, and creating products for the benefit of people worldwide. Phosphates are vital to the development and growth of crops, and so the fertilizers created from phosphates are of growing importance to global farmers, where strong root growth has become an ever more critical factor. That's why we don't just mine better and smarter, or even refine our production techniques to produce better performing fertilizers over a wider range of soils. We also mine new ideas, refine them, and then spread them to all 4 corners of the globe.
En donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur manager, futur ingénieur manager, de se retrouver, mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable. Du Royaume du Maroc et du continent africain.
Hi guys, we're back for...
En donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie.
Our live coverage of SYMPHOS 2017, we're here in Bingrir at the Mohammed VI Polytechnic University in its brand new campus. And well, we have a pretty interesting program for you this afternoon. First of all, we're gonna start with a little workshop at the Bukra room, presented by Boaz, who's gonna talk to us about the new trends of digital mining vehicles and their smart onboard technologies to help our industry keep moving forward. Then we're gonna go back to the Africa auditorium in the big room in the conference center for the third plenary of the day, which is gonna be about replacement and maintenance strategy, and it's gonna be presented by Professor Pascal Dubois-Danguien from Belgium. Afterwards, we're gonna move to the Jean-François Farr room, where we're gonna hear from Mr. Gunther Schron from Germany. He's gonna talk about screening technologies in the phosphate production. And then we're gonna move to the Green City room for a talk from Madame Marcena Small from Poland, who's gonna talk to us about her recommendations for sustainable use of primary and secondary phosphorus sources in Poland. I'm sure we're gonna learn a lot about it, and it can be, of course, applied for every country. This kind of research to make phosphate use and phosphate availability more sustainable, more durable for the future. Then we're gonna move to the Gantour room to hear from someone from OCP Morocco, Mr. Amin Belhadi, who's gonna talk to us about factors impacting implementations of lean production in industry processes. And it's a case study of the Moroccan phosphate industry, and I'm sure we're gonna learn a lot about it because bettering our processes is really one of our main priorities here at OCP and in the whole industry, in order to really have the most rational use of our resources. Then we're going to move to the Safi room. We have a speaker from the USA, Mr. Liam McNamara, who's going to talk to us about a trademarked new technology, which is called Next Step. And it's a flotation rotor, which has been developed from a fundamental point of view, which is really they engineered it back from the laws of nature, and we're gonna learn a lot from Mr. McNamara. Well, afterwards the poster stand. There'll be a poster presentation by students, and then at 8 p.m. we won't be live for that. We're gonna have a gala dinner here with all the attendees and the speakers, and well, I'm absolutely sure we're gonna have a great time again this afternoon.
En donnant en 2012 le coup d'envoi de la construction de l'université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohamed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque futur ingénieur manager de se retrouver mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification.
Who hold a master in chemical engineer and joined also DuPont in 2009, involved in revamp of many projects. So the floor is yours to share with us your experience. Please.
Thank you. Good afternoon, everybody. Thank you for being here. It's a pleasure for me to be here with Pascal and to present this paper and to share with you our experience. So the topic of our agenda we will start by introducing our company. Then Pascal will present the MEX offering and the way we approach the maintenance strategy. I will go on with the case study, replacement of acid towers. Then Pascal will continue with an example of other replacement projects. We'll finish then by a testimony presented as a video. So MEX, who is MEX? MEX is an American company that was established in 1917. The company was acquired by DuPont in 2010 and is now part of the Clean Technology Division. MEX has a deep experience in designing of acid plants, construction and operation of those plants. Our core business is indeed to provide process technology, including license, and most of the major equipment that are required to build an acid plant. It is a combined experience for MEX, about a century experience in engineering of sulfuric acid plants, and for DuPont, more than a century in operating those plants. A combined experience that makes that we are the leader, or certainly one of the leaders in the sulfuric acid technology. Through this decade of experience, what can we say about the MEX the plants that MEX design and deliver to the clients all over the world. They are safe because we have a good understanding of corrosion and handling hot acid and steam. They are environmentally friendly, meaning that we will design them to generate low emission, generally the level of emission which are dictated by country or region regulation. Our plants are also designed to optimize the energy recovery. The MEX plants are known to be reliable and easy to operate.
Thank you, Youssef. So before we jump to the strategy for maintenance, I would like to present a little bit why MECS is your best partner in your plant operation. So this is a little bit MECS team. So we have field specialists on site, which are there to identify problems to plants, and together with the plant equipment specialists and the process people from our engineering team, we are providing a solution to your problems. Now, once the solutions is found, then the project management team is starting and is building equipment together. Well, is designing first equipment again with plant equipment specialists, with process people, and mechanical engineers, and at last we are contracting local partners to build those equipment and install those equipment on site with our field specialists that will make sure that the equipment is starting properly. So that's a little bit how we are operating, and obviously we have a safety team which makes sure that all this is done on a safe manner. So now, what are we offering? This is a typical plant design. Here it's with our HRS system. It's actually the plants that we have built in the ODI plants of OCP. So that's the sketch, and this is a bit what we are offering. So as you can see, we are offering all what you can find in an acid sulfuric plant, from towers, coolers, pump tanks, and Youssef will talk deeply about towers. On the gas section, we can offer converters, steaming equipment, so kind of everything. Sky is the limit, I would say. And of course, we are not only offering equipment. For each individual equipment, we also provide all the process-related matter, so to make sure that the equipment is operating the best manner. About our experience, here you can see a little bit some achievements over the last century that we have been engineering and providing equipment to sulfuric acid plants. As you can see, the numbers are quite significant, from full acid plants to large charge equipment, smaller equipment, and obviously a countless number of hours of field service and customer support activities. Now, let's go to maintenance strategy. So my experience has been showing that you see in plants two types of strategies for replacement of equipment. So one strategy would be to maximize the equipment life and replace the equipment after it fails. Obviously, that brings, that is limiting the investment for that equipment, but you may risk some long plant downtime waiting for that equipment to be supplied. What MEX is recommending is to replace equipment proactively by monitoring the equipment performance during operation, or to perform inspections during shutdown. That will maximize the plant production time. And I will go deeper in those inspections. So Well, this is inspection during plant operation. Of course, during operation, you have many information which is valuable, and the key is first to monitor all your process parameters, can be pressure drop, temperature, acid concentration. All this gives a lot of information on how the equipment are performing. I can give an example. If pressure drop is suddenly increasing a lot in an acid tower, that may be the mist eliminator which has plugged and that will finally completely be destroyed. Other tests that can be done is stick test, simple wooden sticks that we put into the tower to see if we have acid carryover after towers. We can do mis-sampling, or even simpler, looking at your stack. And we can also do, and Mexican support on all this, we can do some Pegasus, what we call, which are SO2 analysis. So we can analyze your SO2 content in different part of your plant. Can be in your converter to see how efficient are your catalysts, but can also be the looking after leaks in your gas-gas heat exchangers or many other locations on your gas section. So that was during operation, and another critical time to perform inspections is during shutdowns, where we physically do visual inspections of all the equipment to look for corrosion, acid leaks, or any type of defects in your equipment. And we can also do some measurement, like measuring your catalyst activity, doing thickness measurement, eddy current testing. So there are many type of inspection that can be done during shutdown, and that we recommend doing this. If you have difficulty accessing some areas of equipment, we have cameras available to look into those equipments. So now I will give the word back to Youssef, who will study the case of replacement of alloy towers.
Thank you, Pascal. So the offering that MEX that Pascal just presented is quite wide. Because we replaced many of them those 2 last decades, especially from our office in Belgium, and because it represents quite an important investment for acid producer, we would like to speak a little bit more about replacing acid tower. So let's start by defining an acid tower. It is a cylindrical vessel inside which a reaction of absorption will take place between a gaseous phase and a liquid phase. In the case of a drying tower, strong acid is used to absorb the moisture that is contained in the process air. For an absorbing tower, interpass or final tower, the acid is used to absorb the SO3 which is contained in the gas stream. A column of packing is used to ensure the mass transfer between the 2 phases. The gas enters the bottom of the tower and flows upwards in countercurrent to the acid that is distributed from the top side of the tower. Before leaving the vessel to go to the next equipment downstream, the gas or the dry air will pass through this compartment where are located filters. The aim of those filters is to eliminate, to remove the acid mist that has been produced during the reaction. Nothing is eternal. We mean by that everything gets eventually deteriorates. The typical tower lifetime is about 30 years, but after so many years of operation, problem may have already started. Acid leaks may occur more and more often, and they can become an issue for the safety of the workplace. Needless to say that the time and the money to fix those leaks becomes also a big concern. You can see picture of those example of deterioration. Acid bricks getting loose to each other and making in this picture that the arch is not anymore self-supported. Sorry. The tower is basically an empty shell. Internal components deteriorate as well and will also need to be replaced. You can see picture of cast iron acid distributor full of sulfate. Here, a failure in the aludurbine part of a packing support system in a brickline acid tower, and here a huge amount of sulfate on mist eliminator. All those internals will have also to be replaced by not by equipment in kind, but by better, high efficient equipment that MEX can offer. So, which are the criteria that plant manager will consider when buying a new tower or more generally new sulfuric acid plant equipment? The cost, of course. The performance, production capacity, and emission will have to be guaranteed. The longevity, the new tower will have to last as long as the current one. It must be reliable. Repairability, in case of a leak, it must be quickly and safely repaired. Safety of the workplace, during operation is important, and the time. The question will be, how long will it take to replace the current brickline tower by a new acid tower, or given differently, is it possible to replace it during the yearly shutdown? The answer is yes. MEX can help acid producer to replace their tower in less time than the duration of a cold shutdown. We can say that because we made it many times for many clients worldwide. So the debate, brickline versus alloy tower, is the classical debate or question that raises every time acid producer have to take a decision. For nearly a century, the acid tower have been fabricated from acid brick. It is in fact a carbon steel shell lined with acid brick and in between an acid-proof membrane. This execution has merits and demerits that all players in the acid industry will agree on. We speak of bricks, we speak of low material cost, but high labor cost. Indeed, you will need highly skilled masons that are not easy to find. It depends, of course, of the size of the tower, but we speak generally of 3 months of fabrication. From the quality standpoint, it is a precision work that must be very well done. From the maintenance standpoint, it is intensive. At least once a year, maintenance people will have to ensure the good condition of the brick and to perform frequent inspection and repair of the support arches. And in case of a brick failure, it is difficult and costly to repair, and it leads generally to a long time out. One advantage that people of the acid industry will almost all agree on is that brickline acid towers are operationally very forgiving, meaning that they can handle excursion of acid strength, as it happens, weak acids, and it will not have a bad consequence on the mechanical integrity. So why the MEX Z-Corrosion alloy tower are preferred over the brickline acid tower? Because they have a lot of merits. The first one, they require less on-site construction time. The reason is that the towers will be fabricated in the workshop prior to the shutdown. As I said earlier, and in the case of a replacement in existing plant, they will be quickly installed and on the same foundation after minor repair or adaptation. Because the alloy towers are 3 to 5 times lighter than the brickline acid tower, the foundation cost will be much more lower. The alloy tower require virtually no maintenance. The only thing that maintenance people will have to do is to measure thickness, and this can be done even during operation. And they are easier to repair, meaning that in case of a failure, it can be quickly and easily repaired by local replacement of the alloy by welding. 2 points that could be seen as disadvantage, but which are in fact not. We speak of premium materials. Alloys are expensive. However, as an offset, less material will be used compared to the heavy brick lines. The other point is that they require operational excellence. The alloy tower should not be operated out of the acid desired strength and temperature. To help in this instrumentation, to control in continuous the acid strength is required. Some of the benefits of the MEX Z-Corrosion alloy tower, when they are properly operated, the alloy tower will virtually not corrode. This means that there will be less sulfate formation in the acid circuit, thus cleaner tower having a high efficiency. There will be low iron in the acid, thus an acid of better quality. And since there are no brick, no mortgage, there will be no risk of damage to acid pump. All those benefits make that the costs and downtime due to maintenance will be drastically reduced. The family of Z-Core alloys, so what do we mean by Z-Core? Z-Core are proprietary alloys that MEX developed exclusively for sulfuric acid application. The first one, the Z-Core Z, is a high silicon austenitic stainless steel that is ideally suited for 93 to 99% strong sulfuric acid. We use it not only to design and build acid tower, but also for other products, like, for instance, acid distributor, pump tanks, acid piping, and also acid cooler without anodic protection on fresh water. The other member of the family is Z-Core 310M that we use specifically for application above where the acid strength is above 98.5%, like it is the case for the gas inlet nozzle in an interpass tower. We use also the Z-Core 310M for high application temperature, like it is the case in the MEX innovative heat recovery system. As it must be done for any metals that one's desire to use for a specific fabrication, the Z-Core alloy have been through a lot of tests in order to verify critical properties, like, for instance, the weldability, or again, the weld resistance to corrosion. MEX engage as well experiment with trace contaminants, since we know that fluoride and chloride have a negative impact on the corrosion resistance. Z-Core Z stands for zero corrosion. It has, in fact, very low proven corrosion rate in strong sulfuric acid. The graphs you can see here shows ISO corrosion curve of Z-Core in strong sulfuric acid in function of temperature and acid concentration. What we can see is that Z-Core Z can operate through a wide range of acid concentration, and from cold acid up to 120. The Z-Core Z, we can see also that Z-Core Z is not suitable for this part, so below 90% of acid strength and above 99.5%. We mentioned that in this area of concentration, the Z-Core 310M will be suitable. We can also see that for application, for drying tower and absorption tower application, the range of operating condition is in this area of the graph, and we can see that the corrosion rate will be all the time less than 0.025 millimeter of corrosion per year. We'd like also to mention that this is based on static immersion, but in reality, the Z-Core alloy tower and the other alloy engineer products in operation have shown corrosion results which are matching or even exceeding those tests from the laboratory. Weak acid is the enemy, one of the enemy of sulfuric acid plant. There is a potential risk of formation of weak acid in this area, which is a gas in a nozzle of typical drying tower. Since Z-Core Z, neither Z-Core Z and Z-Core 310M are suitable for this acid strength, MEX is using a lining, which is a proven fluoropolymer, to protect this part, to make sure that it will not be attacked by weak acid corrosion. So to have even the best alloy corrosion resistant is important, of course, but is only half of the story. Process expertise is also even more important. So the keys for designing a good acid tower will be acid distribution that must be uniform and accurate, that must limit the misgeneration, and that must be designed so that the walls are always welded. Gas distribution is also important. For that, we will design and orientate the gas inlet nozzle in such an angle to have the best gas distribution, and the contact between the gas and the acid must be optimum. All these will make that when replacing, in the case of replacement of tower, there is also an opportunity to make a reduction, to have a reduction of pressure drop, and we will go then for what we call a high efficiency tower. So what do we mean by high efficiency tower? To put a simple definition, it is a tower with the highest absorption or drying efficiency, with the lowest pressure drop, and with the lowest acid mist carryover. How do we reach that result? By the use of optimum equipment. The first optimum equipment is a MEX packing support grid, which has the feature to be flat, which provides an equal packing height and an equal gas distribution. The selection of a high-capacity packing is also important. We will use for that super saddle, which provides also an optimal mass transfer between the phases. The use of the MEX uniflow acid distributor that we designed with a density of distribution of 43 points per square meter. This density of distribution ensure the complete coverage of the tower cross-section, including a good wetting of the walls. Mist eliminator can also be upgraded for lower acid mist carryover. So once the process design is done, the engineering, mechanical design drawings are completed, we can start with the fabrication. To help in that, MEX works with a network of qualified shops, which are experts in stainless steel fabrication. Not only they are experts, but we will train them in Zicor welding technique. We will also perform several inspections during fabrication at critical stage to make sure that the quality is in conformity with the MEX standards of fabrication. Transport to site from the point of fabrication, based on the information we will provide to the transporter, like the weight, the size, the number of sections. This transporter will perform the rigging study and determine the best road to follow. So this is a picture of a load at site. Erection on site prior to shutdown. This will be the case for a big size tower or when there is no available big crane. In this case, we will fabricate the tower in sections that we will transport on site to make over there the final assembly. This slide to explain that the lifting lugs and the shell will also need to be designed for the heavy loads. So the shutdown work starts, and we can have two scenarios. The first one, the old tower is small enough, light enough to be lifted out in one piece. This connection and lifting out can be done in 1 to 3 days. The second scenario is the old tower is too big, too heavy, and cannot be lifted out. We will then demolish it on the same place, and this will take more time, from 2 to 3 weeks. 1 to 7 days will be required to repair the foundation, including the drying of the concrete. Some adaptation can be necessary to welcome the new grillage and the new tower. Lift into place, half a day to 1 day. To mention that for small size tower, this can be done with all the internals pre-installed. Installation of the packing support grid also can be done in several easy to handle sections. A word about the best way to design a packing support grid. The key is really to keep the surface all the time wetted. The picture at the bottom here shows, for instance, a poor beam design with a dry spot on the bottom face, which will lead to a risk of corrosion. So some benefits of the Zicor packing support grid: they require no maintenance. There is no risk of thermal shock, as we could see in the first picture with the alluder beam, and retrofitting in a brickline acid tower is possible. Installation of the Zicor Z uniflow acid distributor under the MEX supervision. What is important here is to have all the elements of the distributor, acid header and trough, properly tightened to avoid any acid leaks inside the tower. Quickly, some benefits of the uniflow acid distributor. They are easily adjustable on site to specific acid flow thanks to manual gates. Since the troughs are wider and deeper, we can observe less surface disturbance, very good acid distribution, and a good weighting of the wall, which will avoid bypass. They are easily to install and require low maintenance. To finish installation of the mist eliminator, and here what is also important is to make sure that the elements are properly tightened to the pedestal. So to finish, 3 to 5, yeah, it could be, 10 days will be necessary to reconnect the piping, ducting to the existing circuit and to complete the platform around the new tower. Pascal.
We have 10 minutes. Okay, thank you, Youssef. So our equipment have a lifetime, unfortunately, our presentation as well, so I will go quickly through the remaining, and maybe we'll have enough time for the testimony. So I will present other type of projects that we can have. Here it's a converter. So you might have seen presentation yesterday from my colleague Tom about catalysts that we can find every shape, every type. We obviously can also provide converters, which is made fully in stainless steel and can be replaced. Can replace old style converters. This is always, like I mentioned, process. There is always a process study which makes sure that you have the best conversion in your converter. Okay, we can have piping system projects to replace old cast iron piping. This is also made out of Zecor and with all the benefits that Youssef presented. Similar as towers, we are providing pump tanks also in Zecor to make sure we don't have corrosion due to the dilution water and formation of weak acids. We have a specific water dilution system with coated sparger and sleeves. So coolers and heat exchangers. We have our MECS coolers, which can be made out of Zecor or with anodic protection. We also built shell and tube heat exchangers or Montplex heat exchangers, which are plate heat exchangers. We can retrofit a shell and tube heat exchanger with a Montplex that is doable. Our HRS equipment, so if you have an old interpass absorbing tower, we could eventually replace this IPA tower with a complete HRS unit, which brings additional to a new tower. It brings a maximum energy recovering in terms of steam. For the furnace, we can provide, well, typically we would not do a complete furnace, but we provide solutions, engineered solution, like vector walls, which are designed to replace typical baffles and optimize the gas mixing in the furnace, all together with a good sulfur gun from our design. On the gas side, we have some critical gas valves that we can supply, slide gate valves, butterfly valves, or jug valves for bypassing the waste heat boiler. And to finish on the other type of big projects, we can also provide waste heat boiler and other economizer, superheaters, well, all steaming equipment. The particularity with our waste heat boiler is that we provide also X-Pro ferrules, which is very easy to replace during shutdowns. This is those fuels are installed without motor, so it makes the operation very, very easy. Okay, that's all for the replacement project, and I would like to conclude with a testimony from one of our Russian customers about a waste heat boiler replacement, if that works. Oh, shit. No. Okay, here we go.
My name is Maxim Petrov. I am the Director of Maintenance and Repairs of the Industrial Group Phosphorit. My duties include the operation of all equipment, supervision of its operations, maintenance and replacement of old equipment. Additionally, we participate in all construction work around the plant. For over 10 years, we had a system consisting of a boiler made in Poland and a boiler section made in the Ukraine, but this did not provide the performance we had hoped for. So we replaced the two boilers with a 150-ton boiler from Max. And this solved our problems. Currently, we are working with this equipment. Last year, we implemented a large boiler replacement project for the sulfuric acid production. The project was fully developed by Max. The main piece of equipment we used was a boiler manufactured in India. It was delivered and installed here directly with the help of our subcontractors. There were a number of subcontractors responsible for specific aspects of the project. The main work was done by our subsidiary, Kingisep Rimstroy Service. All work was carried out in time. The boiler was commissioned last October according to plan. With the support of Max specialists, it was then directly brought up to design capacity and has so far operated at design load.
Okay, thank you, everybody. If you have any questions, I invite you to come to our booth, which is 2829. Thank you.
Thank you, everybody.
Okay, thank you very much for this exhaustive and detailed presentation. So we do not have more time for a question. So if someone have any question, he can contact you directly. So for the next presentation, the floor is yours.
Good afternoon, gentlemen and ladies. We have these afternoon sessions on the phosphoric acid. We have 6 papers. First paper is by Mr. John Wing. It is on Hemi versus dihydrate. Why Hemi is often better choice for the phosphoric acid. This is the title of the subject. Mr. John Wing, almost all people who are in the phosphoric acid industries, they know him very well. And especially, I do not have a speaker form, but I know him since so many years. I had taken a training under him in the IFDC. and he has nurtured my phosphoric acid and phosphatic fertilizers technology, especially in 5 countries, and he has given one of the best training. In addition to that, if I narrate my own plant example, where he has transformed the plant which was not working, it has made working excellently. And that is his strength. And we will be getting a lot of information, practical information from his presentations. Thank you very much. John Wing.
Thank you, Mr. Patel. He was in charge of my first India project, and it was named India Phosphate Plant of the Year, and everyone was happy. I am also very enthused to be here at Morocco, in the phosphate capital of the world. I come from Florida, which years ago was the phosphate capital of the world. Now we're running low on reserves and maybe have another 2 or 3 decades worth. Compared to Morocco, you have how many centuries worth of phosphate rock? I want to commend all who are in the phosphate industry in Morocco, especially the people with OCP and Mohammed VI University, for the role and commitment you have to providing fertilizer that will feed everyone in the world. And in fact, that includes all of us in the phosphate industry for our roles in helping to feed all in the world. I want to talk about the HEMI process, why it can often be the better choice compared to the conventional dihydrate process. The dihydrate process is the conventional process. It has made most of the phosphoric acid ever produced in the world. It produces it typically at a concentration of 26 to 29%. The hemihydrate process was developed for the specific purpose of making highly concentrated phosphoric acid directly from the filter at about 40 to 42% P2O5. There is also what I call a double extra fancy process, the hemi-dye process, which has a second reaction system and a second filtration system that provides benefits of extremely high P2O5 recovery. There are what I would call the 3 E's of hemi. The first E is it is economic. I'll present some things that are typical but don't apply to every situation. Regarding capital cost, I think it will typically be less capital cost for the entire phosphate operation, starting with rock feed and ending up with phosphoric acid out and gypsum discharge. And it might typically be 20% less capital for that entire complex. That was determined by one owner at Indo-Jordan 2 decades ago. It requires no rock grinding with typical rocks. Any concentrate or any rock that is less than 2 millimeters particle size. It cuts out most of the evaporation because you don't have to concentrate from 26 to 41%. And so that eliminates over half of the evaporators. You save consequently, about 70 to 80% of your evaporator steam. You greatly reduce cooling water. There is no 26% acid handling facilities because there's no 26% acid. The reaction and filtration section have to be a bit fancier and a bit more expensive, but there are further economies down the road. There will typically be lower operating cost with Hemi than with dihydrate. In many situations, you can have actually a better overall P2O5 recovery, even though you lose more P2O5 in the filter cake, and I'll explain more about that aspect later. You recover more P2O5 in a plant where you have a wet stack and you're recycling the water back to the filtration system from the wet stack water. And you'll use about 4% less sulfuric acid. This morning, Peter was saying that you'll save about 9%. So anyway, there is substantial sulfuric acid reduction. You generate a lot of electricity from all that steam that you would have used to evaporate from a low concentration to a 41% concentration. If you want to utilize the gypsum, there will be less P2O5 in the gypsum because by the time the gypsum gets through the plant, it kind of thinks it's been through that fancy Hemi dye plant, and so it will have somewhat less P2O5 in the gypsum. And if you're wanting to utilize your gypsum for some of the requirements that require low P2O5 in the product, that will help get you there. Also, since you have a much lower sulfate to P2O5 ratio in your reactor acid, you will, and for other reasons having to do with aluminum and so forth, you'll have at least 2% higher percent P2O5 in the fertilizers that you'll make. That is important in Florida. It could be of no value in other places where you can easily make the 1846O DAP. The Hemi process is easier than the dihydrate process. I have converted 2 dihydrate plants to Hemi, and the owners of both of those plants report that it is easier to run as a Hemi plant than as a dihydrate plant. It's more tolerant of changes in rock feed. The P2O5 concentration in the reactor acid is not crucial like it is in a dihydrate plant. And one client said it's one sweet plant to run after he got going on Hemi, and another one says it forgives upsets, and they both agree that it's easier than that same plant had run when it was a dihydrate plant. You eliminate or reduce entire plant sections. And so that's got to be easier if you have sections that don't have to run, or you only have a fraction of the section. Like you usually do not have any rock grinding requirement. Any rock that is less than 2 millimeters particle size, that's about 9 mesh, either dry or damp, dripping wet, and you can still have more water. Now you can't wet grind the rock and use the Hemi process. If the rock is like a pebble and you need to grind it, you'll need to grind that dry. But that is one rock that is a little less attractive to use with the Hemi process, but you still might want to dry grind it and you go Hemi. You have a lot less evaporation, a fraction of the number of evaporators, and like depending on concentration you're needing to go to, you'll save about 70 to 80% of your evaporator steam, and that typically goes to generate electric power, which you can either use for other facilities by the company or export and sell it. You need fewer evaporators, so there's a lot easier that if you don't have all of those evaporators to run. Most of your cooling water load in a phosphoric acid plant is for cooling of evaporator condensers, and so you'll save most of the cooling water. Less acid handling because you don't have to handle any 26% acid. And you have very little, if any, requirement for clarifying. You'll settle it just for handling purposes. Special techniques are needed in filtration, and that encourages some extra attention to the filter design and filters that are well designed for Hemi operation. This is a graph of the dihydrate and hemihydrate concentration and temperature ranges. And a dihydrate reactor will want to operate in the dihydrate zone, and a hemihydrate reactor will want to run in the hemihydrate zone, and no reactor wants to run in between. That transition shows as a, how do we do the pointer? I guess the other way. There we go. Like with dihydrate, you'll want to be running down here below that transition. With hemihydrate, you're well above the transition, so you don't have to worry about getting into the transition where you'd have a mixture of crystals of, like here, some hemicrystals along with the dihydrate crystals, and the crystals don't know what they're supposed to do, and they generally do bad things. So you don't want to push into that transition zone. With hemihydrate, you don't have to worry about it. You're well below it. And by the way, that transition on to anhydrate is something that you would rarely need to get that hot, that concentrated. Regarding the energy efficiency, this is for a typical plant where you're concentrating 1,500 tons a day of P2O5. The evaporator steam savings I estimate at 11.5 million tons per year. Crucially, that is based on a figure of 10 cents per kilowatt hour, and that figure will vary up and down. 10 cents makes it easy to adjust up or down in your costs, but at 10 cents a kilowatt hour, if you're making 41% acid directly from the evaporator, you will save 2,000 tons a day of steam. You can generate about 115,000 megawatt hours per year, and that will save about $11 million annually. Also, you save a lot on motors, particularly since you don't have rock grinding. You save typically close to 3 megawatts there. Your evaporator and acid handling motors would be running about a megawatt. You're using a lot less cooling water, so you'll save close to a megawatt there. Looking at savings of 4.7 milliwatts, so that's worth another 3.6 million per year in total motors. And so we're looking at saving around $15 million per year, or about $31 per ton of P2O5. So the savings can be quite substantial. This is the Indo-Jordan Hemi plant that was built about 20 years ago. Runs nicely as a Hemi plant. Here for a 700-ton-a-day plant, you see in the foreground 2 fairly small evaporators, and that was concentrating from 41% to, they required 54%, but it's just as easy to make 56%, and since they were shipping it to India, why they would push it on up to 56% P2O5. This is one of 3 Hemi plants at Ma'aden in Saudi Arabia. Each one is rated at almost 1,500 tons per day. So that's a lot of P2O5 produced in one place. I guess you folks in Morocco are very used to producing a lot of P2O5 in one place. So you might want to consider Hemi dye under certain situations. There is considerably more capital cost and a lot more operating complexity. You have 2 reaction sections, 2 filtration sections. Now the second section is less complicated and less expensive than the first, but it's a substantial increase in capital and operating costs. You get extremely high recovery, typically 98.5, straight from the filter. It can be very attractive if your rock and sulfur cost are quite high. It can be very attractive if you need exceptionally pure gypsum. And since you have very low P2O5 in the gypsum, why it meets most requirements for gypsum to utilize. For instance, in the cement industry and various other advanced reactions. And the other benefits of Hemi dye are similar to Hemi. I've done 2 projects where we converted from dihydrate to Hemi and did the basic engineering for another project to convert from dihydrate to Hemi dye or Hemi. You save most of the evaporator steam. You generate a lot of co-generated power. You reduce the sulfuric acid requirements about 4%. Overall, P2O5 recovery can improve even if you're losing more from the filters. Typically, you'll lose an extra 1 or 2% from filtration, but not necessarily. You can run the test and find out exactly where you'd be compared with dihydrate. You eliminate the rock grinding. You reduce other sections, as I pointed out. You get purer phosphoric acid and purer gypsum byproduct. A 2% higher fertilizer grade, which is very easy if you're struggling to make that. Thank you. My first Hemi project was for Belladune, a Prayon dihydrate plant in the backwoods of Canada. We had a Prayon reactor with 9 square compartments, very suitable for Hemi hydrate. In fact, even more suitable than Yara was offering as the Hemi reactor. The filter was a bird prey-on tilting pan filter, about 90 square meters. The rock was initially Central Florida and then a blend of Central Florida and Morocco rock. We needed to increase the capacity from 500 to 550 short tons per day. It ran with 95% recovery based on filter. We had a very easy start. It met all guaranteed performance requirements within 19 days after day one. And the client says it's one sweet plant to run, and it was easier than they had with dihydrate. A few years later, we converted a similar prey-on dihydrate plant in Arcadian, which is in Louisiana. Similar size reactor, slightly larger, more modern bird pans. The rock was Bucra rock from Morocco, which is really one sweet rock. The capacity increased from 560 to 720, easily 720 short tons per day. It consistently operated at a 96% P2O5 recovery based on filter losses, which I think is probably the best of any Hemi plant in the world. We had an even easier start for that. We met all guarantees within 2 days, and Pierre Becker, who wrote the book on phosphoric acid, just happened to be on site for some totally different project, and I had the honor of showing Mr. Phosphoric Acid through the Hemi plant at 11 o'clock at night when it had, after 40 hours, it was up to 100% capacity. And the client, again, said it was easier than it had been before as a dihydrate plant and more forgiving. Another thing you might want to do if you want to increase the capacity of an existing dihydrate plant up to about 50% extra capacity, you don't need any more evaporators because you're eliminating your need for 2/3 of your evaporator unit. You don't need rock grinding with -2 millimeter rock. You need a whole lot less cooling water, so you don't need to expand the cooling water capacity. You can increase substantially without expanding the acid handling, because you don't handle any 26% acid, so that's a whole bunch of tanks that can be used in other ways. A Hemi plant only needs about 65% of the flash cooler duty, so that there are less flash cooling size requirements. You can convert from dihydrate to Hemi-di while expanding the capacity and get some other benefits like I've shown here, and we'll move on to the next slide. This is really not for a good slide for display during a presentation, but it has a lot of detailed comparisons about various issues, Hemi versus dihydrate versus Hemi-di, and this is in the accompanying paper. So the 3 E's of Hemi, it's economic, low capital cost, low operating cost, it's easy to run, and it's very energy efficient. And before we wrap up, I might invite you all to come to Florida, where we have a very nice phosphate conference every year at Clearwater. It is a fun weekend at the beach and a lot of good technology provided and a lot of opportunities to meet colleagues in the industry. There are years of phosphate paper. They're free to all online. You go to that website, or if you forget the name of the website, just Google AICHE Clearwater, and that should get you there. all papers for decades are available for free to everyone online. You don't have to have been to the conference. So now I'll be glad to field questions that you may have.
Any questions?
Paul Smith from Brazil. Thank you for your paper, John. A lot of good information. There are lots of advantages of Hemi. You mentioned some of them or most of them. But why did Marden change from Marden 1, which was hemihydrate, to dihydrate on Marden 2? What do you think were the overall pressures which caused them to change their mind?
I don't know the details. That was a different phosphate rock. There were different situations inland, and I was not involved in that decision to go dihydrate rather than hemihydrate.
Thank you for this presentation. So we can just agree with most of what the statement you made here, and I may complete this by one advantage of the hemihydrate is economy of water. So we know the scarcity of water in the world, and we know that hemihydrate process consume less water compared to dihydrate process.
That's right.
So, however, we cannot make, this is my comment and my own opinion, we cannot make a general comment or statement stating that Hemi is better than dihydrate or the reverse dihydrate is better or any process is better than the other one if we don't know the conditions in which we will be applying this process. I will give example. In some case, when we have scarcity of water, the cost of energy is very high, so it will be obviously hemihydrate will have great advantage. But in cases in which we have pipeline, for example, and we are transporting the rock with water, so if we don't want to apply the hemihydrate, it will be very complicated. So we have to dry the rock, we have to filtrate, and the cost will be tremendously expensive. It will not be comparable. So that's why it's really debatable, and I think that each process has its own advantage and disadvantage, and surely hemihydrate has its advantages, it has some disadvantage. I can say some of them. Some of them, for example, the high consumption of defumer, it's very high compared to dihydrate. In dihydrate, in some cases, we don't have to consume defumer at all. And when we consume, it's limited to few hundred grams per ton P2O5. For hemihydrate, it's kilogram. And this is real and high cost. For hemihydrate, it's high temperature, high corrosive, it's highly corrosive, so we have to select for all the material alloy which are expensive. The lifetime of the equipment is less. So we have to add silica or alumina to prevent against corrosion. So all these, but not to say it's not good as a process, it's good, but still there are disadvantages, and we cannot just say it's better or not better. For any case, we have really to make complete study to consider into account the country, the area, the weather, the availability, the cost of power, everything, and no one can, in the world, according to my own opinion, state that this process is better than the other one. And excuse my direct opinion.
That's
Thank
right.
you.
It's hard to generalize. Regarding the water balance, obviously Hemi can handle less water coming in than a dihydrate plant can. And at the Hemi conversion in Louisiana, we had a tight water balance because the buchra rock needed to be washed on a little belt filter before coming into the plant because it was full of salt water. And it came in dripping wet at like 17% moisture. And there were 2 different scrubber effluents also coming into the plant, and it could handle that and easily. We had a rather limited amount of cake wash water, and despite that small amount of cake wash water, and by the way, we did 3 wash rather than a 2 wash, and it ran consistently at like only 1% P2O5 water-soluble losses, despite being tight on the water balance. So even that worked out rather well. Other questions?
Okay, I think it's over.
Thank you very much. It's been a real pleasure.
Thank you very much, Mr. Wing. We have a next paper from Mr. Zhu Jiahua. He is a professor and chairman of the Faculty of Chemical Engineering School in Tsinghua University. He will be speaking on the research and development of the cleaner wet process for phosphoric acid production without waste gas discharge. If I give him a brief about his education, he is a BS, MS and PhD from the Chengdu University and postdoctorate fellowship of University of Birmingham. He has professor since 1994 and director of provisional key of a laboratory of multi-phase flow chemical reactions since 2005 at Tsinghua University and chief consultant of S&T from 2004 to 2010. With this experience, accumulated more than 10 years working in the chemical compound plants, strong research interests are focused on cleaner technology, R&D, and primary production industries. Let us hear him on this subject, research and development of cleaner wet process for phosphoric acid production without waste gas discharge.
Thanks for introducing me. Oh, so tears. It's my pleasure, and it's my first time to join the SYMPHOS to share some of our work on the research and development about the cleaner WPA process without waste gas discharge. Okay, because this is my first time, so I want to show a few slides about my country. So in our point of view, this is a Great War. In our point of view, Morocco is in this side, and the United States is in this direction. Okay. This is the Yangtze River in my province. The Yangtze River, the upstream, and this is my province, Sichuan province. So they call the land of abundance. So this is the giant pond hall. So it's in the center of the China. It's my province. This is my city here, Chengdu. It's surrounded by mountains, rivers, and some places. So this is my university. I think the friends in OCP, they want to know some of details about my university. So here is my school, chemical engineering school. Okay. Yeah. In my school, we have a big base of phosphorus research center. It's a national research center. We have about 100 researchers and 150 graduate students there. So we research and develop some phosphorus technologies concerned to provide the technologies to the industries in Sichuan and Guizhou and all of the China. So some of the companies you may know. So today, I would like to share some of our work about the research of WPA process without waste gas. The purpose is that we want to recover and reuse the fluorine contained in the phosphate rocks from the WPA process. Some of the data we can see from here, that is in the past 10 years, we get the exact data about the yearly assumption of the phosphate rocks from 37 billion tons continuous increasing to about 60 billion tons per year in China. So that is 170 billion tons yearly consumed, the phosphate rocks the world consumed. That means we have about 5 to 6 billion tons fluorine contained in the phosphate rocks. So compared to the fluorine, the world consumption is only about 200 million tons. That means the WPA industry perhaps is the best alternative resource to feed the world demand for the fluorine. If not, we should ask another question: where does the fluorine in the phosphate rocks going? Where it's going? From some literature, it says about 15% lost to the air. So that is the serious problem to the air pollution, because for the acceptable source impact levels, it is only about 5 to 8 micrograms per cubic meters. And even for the permissible exposure limit, it is 0.2 to 2.5 milligrams per cubic meters. So compared to this big amount of fluorine contained in the phosphate rocks, and its very small allowance standard, we can judge that must be a very serious problem if we do not recover the fluorine from the off gas of the WPA process. So that is the motivation for us to do the work. Here is some information of the Europe countries. They have paid attention to the air pollution accumulated by the phosphate rocks. So that some of the data shows that it's closely related to the phosphor and the nitrate element together with fluorine in Poland, some area. So that is why we designed a so-called clean process for WPA. So firstly, we need to see what is the bottom of the recovery of fluorine from the process of WPA. That is the vacuum cooler. So that is connected to the reactor, digestion reactor. Now here, there is a liquid and the gas interface. So here it is controlled by vapor-liquid equilibrium control. Under certain temperature and the concentration, the vapor contains certain amount of fluorine. Well, when you want to scrub the fluorine from the off gas, even you use a lot of water, I think it's omitted by, this is omitted by the author. So even you use a lot of water, but here, this process to scrub the fluorine, you want to come down from the gas phase to the water, but it may not be exactly the situation because that is mass transfer controlled. Since the droplets of water may not catch every molecule of fluorine in the gas phase. So it still leaves some of the fluorine in the gas phase. So conventionally, use another steam jet to make the waste gas or to the so-called barometric condenser from here and from here to the atmospheric, as well as to the cooling pore evaporation. So that is the problem. Another source from the condensation of dilute WPA. So from here, the evaporation, the purpose is to concentrate the WPA, but at the same time, the fluorine will evaporate from the liquid phase. Again, here, use the water to scrub once and twice. So this time, the people want to get fluorosilicic acid, want to get concentration as high as it can be. But as the concentration is controlled by the liquid and the gas equilibrium, the higher the concentration is, the more escape of fluorine from the off gas. So even you use twice or triple wash, there must still a lot of lots of fluorine escaped to the air or through the hot water cooling tower, evaporated into the air. So the problem is the process combined the fluorine recovery and the heat removal combined together make the things become complex. So if we can decouple these two functions of the process, situation may become better, like this. This is our innovative process. For example, here, is the rock digestion decomposition reactor. So here is the off gas. The initial gas, together with water vapor and fluorine, so as the source of the fluorine, conventionally, so use the water to scrub the off gas. Then scrub the off gas twice or triple. After this, released to the airplane, released to the atmospheric. Now, in our process, we are not scrub the gas. We make the gas, the temperature decreased under the supervision temperature, the point. We use enough liquid flow rate to make the gas from 90 degrees centigrade decreased to about 50. So make the phase changes taking place here. So almost all the fluorine comes down in this adiabatic condensator. Then the off gas becomes fluorine free. So let's to see the condensator. It is dilute fluorosilicic acid. Now we want to make it become the product of fluorosilicic acid. So it will be automatically go into a flash evaporator. So another adiabatic flash evaporator take place here. Separate the water vapor and the fluoride. Leave the fluoride in the liquid phase and the water vapor into the heat exchanger. So it makes the fluorosilicic acid become condensate. The concentration is higher than 15%. Okay. The water vapor here is almost clean, so we can use it as the waste heat energy. So here, we use the heat pump system. Let the water vapor condensate in this exchanger, heat exchanger, and release the heat to become water about 50 degrees centigrade and recover the water. this water is clean, almost clean, then we can use it again to the process. Okay, then the heat will be sucked into a compressor, that is a heat pump, to upgrade the temperature and to release the heat at a higher temperature, higher than 95 degrees centigrade, to use it to heat the cold water, for example, for filtration wash. So here we recovered the fluorine, use recycle. Here we recovered the thermal energy, use this cycle. Then the off gas also become free of fluorine, but it contains some of CO2 in the phosphate. So we can use this process. We use the phosphogypsum and some of ammonia. Use this reaction to convert the CO2 into calcium carbonate and the sulfate into the ammonia sulfate. So this reaction makes the off gas completely clean. Only the inertial gas, air, only air left here. Then we let the gas back to the decomposition reactor in spite of hemi or dihydrate process here. So for this process, we use ammonia as the reactant. So for each ton CO2 sequestered, we need 0.77 tons ammonia. So others, so this is waste. The gypsum is waste. So from this reaction, we did that. We can get 3 tons ammonia sulfate from each ton CO2 sequestered. We spend 0.77 tons ammonia. So here, we make a calculation about the value added. So at last, we can get $68 value added from this reaction. So here is we built up a verification production line in the Guizhou Chanheng Chemical Corporation. It's 30 kilotons per year, the capacities. So we use it and to verify the process. The parameter is like this. Yeah. For example, here, we get the off gas here, raw gas, the temperature 85 centigrade. The mass ratio is 11 tons per hour, and after this, about 3 tons get off. And we can get from this process 0.95 tons per hour fluorosilicic acid output from this. Okay, each point from here is the heat pump. We can get a condensate of water here. This point is water vapor, then condensate in this heat exchanger, condensate here. So this 4 point is about 20 tons steam condensated. We recovered the heat energy here, use it to heat the cold water. So from this process, we can get benefit both from the recovery of fluoride and make the fluorosilicic acid with effective concentration higher than 50%. So its same temperature is 45 degrees centigrade. At the same time, to recover the latent heat, it is chemical react heat from the phosphor rocks decomposition. So we recovered it from this temperature, and through a heat pump, we use the waste heat behind this temperature. So another benefit is we convert CO2 into calcium carbonate and ammonium sulfate. So this is also a value-added process. So after this, the off gas become clean. It can be blown back to the reactor, so there is no off gas discharged to the atmosphere again. That is the main process what I would like to introduce to all of you, and thanks for your comments. Thanks.
Any questions? So there is no question, then we thank you very much, Mr. Chair.
Thank you.
Thanks. We have a next paper from Mr. Leitala Hannu. Is a process engineering manager from Outtake, Finland. He will speak on the green acid purification with the solvent extraction. Mr. Hannu is a process engineering manager at Outtech, Finland. His expertise is in hydrometallurgical processes, including different atmospheric and pressurized leaching processes and precipitations, oxidation and reduction processes, crystallizations, and all the chemical reactions. Over 20 years of work experience in chemical and metallurgical industry, including production, maintenance, process control, simulations, process engineering, and commissioning and startup. Welcome. You have 20 minutes to go.
Okay.
Yes, sir. It's already there. This is a green for forward. This is a go backward.
Okay.
And this is a pointer.
Okay. Thank you. Good afternoon, ladies and gentlemen. It's a pleasure to be here this afternoon and present you very shortly how to connect a solvent extraction process to purify phosphoric acid. Phosphoric acid process, production process is very simple. As you all know, ground ore is fed to the attack tanks, and there we feed all.
Sixth Polytechnic University in its brand new campus, and well, we have a pretty interesting program for you this afternoon. First of all, we're gonna start with a little workshop at the Bukla room, presented by
sulfuric acid. Filtration stage feeds diluted acid back to the attack tanks, and from sulfite removal stage we get also
Blaz, who's going to talk to us about the new trends of digital mining vehicles and their smart onboard technologies to help our industry keep moving forward. Then we're going to go back to the Africa.
The sulfite gypsum slurry back to the reactors here. There. After filtration, usually there is a sulfite removal stage to remove sulfite from the solution, and then is arsenic removal, and then evaporation. After evaporation,
big room in the conference center. We're gonna move to the Georges Far room, where we're gonna hear from Mr. Gunther Schron from Germany. He's gonna talk about screening technologies in the phosphate production, and then we're gonna move to the Green City room for a talk from Madame Marcena Small from Poland, who's gonna talk to us about her recommendations
than siliceous reserves in the worldwide reserve. Separate that, and the professor Philip Powell already talked about how difficult to separate because they have similar cationic ions, similar very finely disseminated, and a similar behavior in the conventional fatty acid flotation. So there's no universal reagent scheme or the process to separate those impurities. And we have to carefully select the collectors, the flotation reagent, and for the develop the optimal the flotation process with the consideration of the current ore body or future ore body. And so this presentation will cover a few examples. We got ore from North Africa, and okay, here are the we're using different chemistry of collectors and a different flow sheet with the reagent scheme. You can, like I said, you can compare the result to see what's the advantage of each one. So we have the five samples from North Africa. We have high grade. The A is like 28% P2O5, have a higher insol, and like 5%. And we have low grade with a size minus 60 plus 400 mesh, and only 20.4% P2O5 and 3.1 insol. And we have two called the C1, C2, two samples without desliming. So it's a minus 100 mesh, it's a 150 micron. And you can see the low grade, the phosphate, P2O5 21, 22. The insol is like 7, 8% insol. I didn't have analysis on the magnesium on this A and B sample. Sorry about that. So this is the two of the process we compared. The first one, we conditioning with a slightly acidic pH, like pH 6, and use a phosphate ester as a conditioning for 2 minutes, and then use amine to conditioning like half a minute. Then you flow this carbonate and silica together, the one-stage flotation. The other approach is we do the more acidic pH environment, like a 5.3. We use a fatty acid type of collector and conditioning, then flow the carbonate first. And then you may need to adjust the pH around pH 6.3 to 7. And then you add amine. You flow the silica. We call this the two-stage flotation and kind of double reverse flotation. Here's the result for the sample A. You can see this one-stage flotation. You also can get 32.6% P2O5 concentrate and 91% recovery. With a two-stage flotation, you can get similar concentrate grade, 32.7. You got 2.3% higher recovery. And we have more examples on another ore, like a B sample. B sample, remember, is a low P2O5, only 20%, but also low insol. We do the same thing. We do the phosphate ester and conditioning for carbonate flotation, amine for silica flotation, flows at one stage. And or we're using fatty acid as a collector and flow the carbonate. Then we use amine to flow silica. Here the sample B result. You have a 20% P2O5, about 45% BPL, we will say. And you can see the two-stage flotation, you got a similar concentrate grade, you have a 4%, close to 4% better recovery. They have more advantage on the two-stage flotation. Two-stage flotation, you can have a no foaming issue and a better recovery. I'll show you more examples, then we have some conclusions. And also, if you really don't want the, you said that the install, it doesn't matter. Some percentage is okay. So you can just do one-step flotation. Also, this is the fatty acid type. And this is very selective. And you can get 80%, this is another sample. I didn't show this ABCDE, maybe the E sample. And this sample we tried, this undeslimed, no desliming. And it's from 20.7% P2O5, and you can concentrate to 32%. And this one we tried the RMS phosphate ester, and it didn't work because of non-deslime. Another example is, I said this is two samples, C1, C3. This is the flow sheet we proposed to the customer, and we using the phosphate depressant, using sulfuric acid adjusted pH, or you use the phosphoric acid only to depress phosphate, using fatty acid collector to fluorocarbonate, and the tail goes through reflow, just adjust the pH. The two of the underflow, the carbonate, and we sized at the 25 micron because very fine particles consume lots of amine. So the concentrated grade is high enough, you don't need to do the amine flow. So we're sizing at the 25 micron, and the plus 25 micron is subject to silica flotation. Very little amine used. Here's the result. So C1, C3, see that from 22% P2O5, after the carbonate flotation and the screening at the 25 micron, see the minus 25 already 25.6, and this one is a 23.7. Because we all know the fine particles consume amine, so we're trying to avoid that. So you combine this fine with the flotation concentrate, you can get the 30% P2O5 with 84% recovery. This is the 82.8 and also 29%. So the customer using this flow sheet doing the pilot test right now. So here's the benefit of the new reagent scheme. I call the double reverse flotation scheme. And you flow the carbonate first, and then you flow the silicon. Compared to the one-stage flotation, and you have better selectivity, and you get the result in the higher recovery. And also, this is easy to adapt to the current plant setup. I'll show you the schematic program later. And also, since we flowed the different time to stage, there is no foaming issue in the plant. And also, this can tolerate the wide sizing range of flotation feed from 250 micron to 0. You know how to deslime it. And like I said, more tolerable to the ore body. Like if you have low-grade feed or slimy feed, and this two-stage fatty acid collector, it will be working much better than one stage using phosphate ester. And also your mine life extended automatically. So here the schematic, adaptation, how to adapt the current process. In North Africa, and we know they have like conditioner, so we can adjust the pH and the carbonate depressant, the phosphate depressant, and then we adjust the pH, same thing, and using conditioner to condition for the carbonate flotation. Then after carbonate flotation, and at the end, you may need to add some little bit adjustment pH, but most of the time, in the reality, you don't need it. You just, the pH already 6.5, 6.3, you just add amine in the between, and you flow the silica. So, so very easy to adapt to this, the existing process. The summary, the flotation result, and the 5 samples from North Africa showed the aromatized carbonate collector and either phosphate ester or fatty acid oil very effective, separating the carbonate minerals from the phosphate. And for modified fatty acid, and phosphoric acid consumption is higher than normal used phosphate ester, but however, you got better recovery. We'll cover that. And also modified fatty collector can achieve the higher recovery because of the better selectivity. And the modified fatty acid collector is more efficient to process the wide range of the sizing and the low-grade feed, and also particularly for the undeslime. Don't need it deslime, or don't need it carefully deslime. Custom-in collector also can effectively flow the silica. So new collector application scheme can be easily realized in the current existing circuit, with a significant economic benefit. Thank you for your attention.
Okay, thank you, Mr. Wong, for your presentation. And I think we have 2 or 3 minutes for question, please. Yes, microphone.
From Arkema. So thank you for your presentation. I'm just a bit surprised with your conclusion concerning the comparison between the type of collector, because at the end it seems that you conclude that the fatty acid is better than the phosphate ester, but in fact for me you don't compare the same thing, because you change 2 parameters, and because in one case you have a 1-stage flotation with phosphate ester, and in the second case you have a 2-step.
Yep.
But I think that if you would have tried the phosphate ester in a 2-stage process, the result may have been different.
Actually, the reason I compare this, because like for some feed you can see especially low-grade feed, like lower than 45 BPL or 20% P2O5, or the slimy feed, for not clean enough the feed, and so the phosphate ester is not that effective anymore. You're right, and sometimes, at least the aromatized phosphate ester, okay, and you float it, you use a second stage, it doesn't work unless you do the same time flow together. It seems the phosphate ester and the amine, they help each other to flow. If you separate that, it doesn't work anymore. So that's why I compared 1 stage. If you do 2 stage, you're better using fatty acid collector. If you do the 1 stage, yes, you can use phosphate ester and amine together. That's my proposal. I say you can try.
Yes, no, but perhaps because it's probably the aromatized phosphate ester, because I mean, with our phosphate esters, we do the 2-stage two-stage process, even with deslime, without desliming, and it works the same. We don't see any efficiency loss or anything like that.
You mean that you do a two-stage using phosphoester without deslime?
Yes, and with amine at the second stage, and it works. I mean, there's no loss of efficiency or something like that.
No, so yeah, it really depends on, like I said, ore to ore, different ore and different. That's why I said the ore really was a determining factor. What process, what collector you use, and also you have economic evaluation and all these things. It's not simple as I presented. Let's just say it that way.
There? Do you know? Okay, please.
Thank you. Luis Rudolph from Autotech. Thank you very much for your presentation. One question actually. Did you conduct this test in the laboratory or like how they were conducted? I think I missed that part.
Okay, the result I presented is all the lab result. Okay. But we do have a practical result we don't want.
Yeah, and that's what
without the customer approval, you cannot share.
Yeah, of course, but my next question was actually, have you seen any difference between the results you get from the laboratory and the results you actually get from a real plant? Meaning, I assume that there might be actually some difference in terms of conditioning, time, and so on.
They do. Some plant lab is better, and some plant, some case, the plant is even better than in the lab. The whole reason also depends on how you conditioning in the lab, and what kind of flotation machine you use in the lab. And so sometimes the plant even better than, surprisingly, like they have 87% recovery, 90% recovery in the lab, in the plant. In the lab only show 78, 80% recovery. Real depends. For those I presented North Africa, the ore, all in the lab.
Okay, because it would be actually good to have also to see that comparison at some point, if, like maybe for a next paper or next research. What is the actual effect of, let's say, the laboratory in these results? Because I think not too many reagent suppliers have ever discussed about that actually. So maybe that would be like an interesting research topic for the future.
Sure.
Okay. Thank you very much.
Yeah, thank you. Question.
I'm not expert in
Technically, we have the X-ray source on top. We have on the top side, we have the low energy channel, and we have the high energy channel. The material is fed across, and after this feeding across, we get two signals of the same rock at the same position, and with these two signals, we can balance out what material is behind it. It gives us an indication of the average atomic density of the rock. You see two rocks here. One is an apatite, one is, for example, a piece of chert covered with some weathered material, so the color is more or less the same. In real life, in real practical life, everything will be dust and dirt covered, so we will not see a color difference like we see here. But you see in the periodic system of elements, the calcite, phosphate, the apatite is more on the left. It's a very, for our X-ray machine, a very heavy, a very atomic dense material, versus the silicious, the SiO2 is a material of a rather low density, very light material. The X-ray sorter can separate the apatite from the chert. What it cannot do, what I circled here with the blue line, the carbonates, the dolomite or the calcite, is not the right approach to use an X-ray sorter. I will come to that a few seconds later. The result of the same rocks you have seen before. You have the two rocks, the one is apatite, the other one is silicious. This is the X-ray picture, how you would see it at your doctor. You don't see a difference. And this is the outcome of the picture of our machine. So you see the pure difference between the apatite and the silica. And the result of this, you see, this is the feed material of a laboratory test, just to demonstrate this. It's a mixture of chert, silex, and phosphate, and at the end, your objective is to remove as much chert as even possible before you go to crushing, milling, flotation, whatever process is behind it. And the result of that, you see the phosphate here, and you see the chert there. And this is not a color sorter, only X-ray. You see in this example we have some pretty good results. Efficiency and recoveries were pretty excellent. I'm not going to guarantee this. They are only valid for this experiment. If we want to separate carbonates as well, we have to look for another technology, which is called near-infrared or proche infrarouge. We need a different mechanical setup. This looks like this. The machine is different. We have different sensors. The principle is the same. You take the rocks, you feed them single, one by one at the side. You scan the rocks with a near-infrared sensor and an additional optical sensor. You analyze the result in an electronic black box, and then you separate the rocks physically by using compressed air jets, separate them into the good and the bad rocks. The near-infrared uses the different absorption spectra of near-infrared frequencies in the different minerals. So you see some example minerals. You see the chlorapatite is the red line, chert is the blue line, so the difference and the behavior, the gradient of the line is seriously different, and also
Hello, Professor Ramakrishna. I'm sorry. Well, we've had a very interesting talk on your behalf, and we saw it live actually on SYMPHOS TV, and we were having our own talk. Thank God it was off camera. I'd just like to hear your impressions about being here in Ben Greer and discovering this university, and what do you think about this type of event and how it helps actually our industry make a better world?
Well, I think when I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what you are putting bricks to build a future. And I think it's really fascinating, and I believe the rest of the world would need to know more about it. And what I saw so far, you have been systematically putting together a strategy and building on that realization in terms of developing the talent and making them relevant to the future industries of not only this region but for the whole Morocco. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me. And I learned it today, and I feel very happy, and I'm glad to be part of it.
We're very glad to have you here, and I think you put it best, but yes, we have to adapt ourselves to the future so we can actually make it. And we'll let you go. Thank you very much, Professor, and we'll see you around these 2 days. Thank you. Thanks a lot. Hello, we're back, and we're finally here with Mr. Boulif, who's going to answer us a couple of questions. Monsieur Boulif, bonjour.
Bonjour.
C'est un plaisir d'être ici avec vous à Ben Guerir au SYMPHOS dans ce très beau campus. It's a pleasure being here on this beautiful campus. What can you tell us about this event and what it represents for your organization? Qu'est-ce que vous pouvez nous dire de cet événement et ce qu'il représente pour votre institution?
Alors SYMPHOS, tout d'abord, c'est un symposium international sur l'innovation autour de l'industrie des phosphates. C'est l'un des plus importants, les plus grands symposiums au monde aujourd'hui dans ce domaine. Cette quatrième édition donc, fait suite à 3 précédentes éditions qui ont permis un petit peu de développer un certain nombre de partenariats dans le domaine scientifique et l'innovation autour du phosphate. Cette année, la nouveauté, c'est qu'on l'organise dans une prestigieuse université, c'est l'université Mohamed VI Polytechnique de Ben Guerir, qui, elle, dans sa mission, entre autres, l'innovation dans le mining. Et donc, cette année, nous sommes dans les 950 000 personnes qui vont discuter sciences, technologie, innovation autour de l'agriculture, autour de l'énergie, autour de la protection de l'environnement, autour de l'industrie du phosphate, des technologies. Nous avons accueilli aussi dans les 105 exposants à travers le monde. Ils viennent des États-Unis, ils viennent de la Chine, ils viennent de Singapour, ils viennent de différents endroits du monde pour promouvoir leurs produits, leur savoir-faire et partager ce savoir avec le monde industriel, le monde scientifique. Comme j'ai dit, nous sommes 43 pays, mais 43 pays dont les scientifiques qui sont là, donc qui des sciences, des technologies, des innovations. Donc ça va permettre, je dirais qu'il y a la crème dans ce domaine aujourd'hui ici. Et alhamdoulilah, on essaye de tirer profit donc, de cette manifestation, monter des partenariats avec les équipes, partager aussi notre savoir-faire à travers le monde. L'objectif, c'est donc, comme j'ai dit, une agriculture durable pour le bien du monde.
Merci beaucoup. Juste une petite question avant de vous libérer. Ce campus est extrêmement beau. Ça donne vraiment envie d'avoir 19 ans et de recommencer ses études, n'est-ce pas?
Effectivement, moi, je suis à l'OCP, mais je viens souvent ici à l'université pour s'inspirer un petit peu, rester dans le domaine, je dirais, universitaire, discuter avec les professeurs, discuter avec les étudiants. Et c'est ça qui donne envie donc, de continuer à faire de la recherche dans le domaine, en général et en particulier dans le domaine des phosphates.
Merci beaucoup, M. Boulif.
Merci et au plaisir.
Excellente journée. Bonne suite.
Bonjour à tous, donc moi c'est Eliman Semben.
Ravi.
Je suis rédacteur en chef de African Business Journal, donc, qui est un magazine panafricain, axé économie, management des entreprises en Afrique, qui est basé à Casablanca depuis 2012. Voilà, nous sommes venus sur invitation de du groupe OCP participer à la 4e édition du SYMPHOS. Aujourd'hui c'est la première journée. Dans l'ensemble, ça s'est bien passé, avec une communication inaugurale qui nous a permis de nous replonger sur l'expérience de Singapour, qui a su s'appuyer sur l'innovation pour devenir aujourd'hui un pays respectable, une des économies les plus développées de la planète même, pour ne pas, asiatique pour ne pas dire international au niveau mondial. Donc voilà, on a appris beaucoup de choses de l'expérience singapourienne. Je pense que c'est un cas d'école qui peut servir d'exemple à d'autres pays qui pourront faire un benchmark sur l'expérience de Singapour qui, en 1950, il y a de cela 50 ans, était au même niveau que beaucoup de pays de l'Afrique subsaharienne. Aujourd'hui, ces pays gagneraient à s'inspirer de l'expérience singapourienne pour amorcer un véritable décollage économique. Donc voilà, l'innovation qui est la thématique principale de cette édition, qui est également un concept sur lequel les pays africains doivent s'appuyer pour véritablement mettre en place l'émergence, pour que ça ne soit pas uniquement un concept creux, mais que ça se reflète dans la réalité, sur le terrain, pour que ça puisse profiter aux populations africaines, pour que la croissance soit inclusive et non partielle.
Très bien, merci beaucoup.
Merci à vous
beaucoup,
également.
je vous remercie
Merci.
et à demain.
À demain, merci
beaucoup.
currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
En donnant en 2012 le coup d'envoi de la construction de l'Université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé
And then we also had a very challenging application where we were testing our 660 cubic meter flotation cell in a scavenger circuit, and the results will be presented here in a minute. So the 1.5 cubic meter results. You can see the results here of different configurations, a normal cell with rotor and stator configuration, one with just the next step rotor, so that oddly shaped rotor that's in the middle, but in a traditional kind of a stator. And then the results of the rotor and stator combination for next step. And what's interesting here is the speed and the copper recovery.
Des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
Very low power consumptions, we were getting very good or better than traditional recovery of the copper. Based on our work that we did, we came up with this particular rotor shape.
On digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables.
The shape that we're interested in here is the upper one, or this one, compared to a traditional one which is on the right or on the bottom. Initially, during the development, we did CFD work, computational fluid dynamics, or some say cute figures for directors, and came up with these different analyses here. What's interesting here is the wear pattern. The lines are really velocity vectors, and you can see where the particles in the air all exit towards the top of a traditional rotor, whereas with this interesting shape that we've come up with, all of those velocity vectors are spread out around the whole edge of the rotor. That reduces your wear. It gives you much better bubble generation and much better contact with your particles. And we also moved the traditional location of the air inlet into the rotor down to the center of the rotor. So then to actually verify these cute figures for directors, we went in the field and had painted rotors. And you can see the wear pattern. So the different layers, blue is the very top layer, yellow is the next one down, and red is the bottom. You can see that we verified that the velocity vectors that were all up here are the same on this one. And this one said that all velocity vectors are going to be on the edge of this new rotor, and we showed improvement there. The next thing we had to look at was, now that we know the shape of the rotor that we want and the stator, we had to look at how many of them do we need? How many blades do we need? Is the traditional numbers of 6, 7, 8, 9, or 10 right? Do we need more or do we need less? And so we did, again, CFD analysis. And you can see the difference between 6 blades, 8 blades, and 12 blades, and the velocity vectors associated with that. We then did field test work, and we showed that there's a step change here between 6 and 8 blades, and the rest of the blades were pretty constant in terms of recovery. So we chose the 8-bladed design. Next, we had to look at the stators. Now, a traditional stator is just a flat plate that sits on the outside of the rotor. And what we looked at, and we had a great idea that we tested, was what if you put holes in the stator? That allows more turbulence behind the edges of the slots, and allows for better particle contact with the bubbles. You can see the analysis we did showed the blue line, which would be a traditional rotor stator combination, and the red line is what we predicted it to be. So again, we went in the field, and we looked at the rotor stator combinations here, and we decided that for every rotor stator combination we looked at, with and without slots, that the slots always produced a better result. Now we went to a pilot scale, and what we were looking at here was how much energy are we using with this different rotor stator combination. And you looked at all of the traditional Dor Oliver's combinations here, which was our traditional rotor stator, with the new next step rotor stator combinations. And in every case, the next step rotor stator combination had much less power draw. As a matter of fact, some of them were as low as 0.3 to 0.4. Next, we went to plant trials and startups. So we'll talk a bit here about some full-scale tests that we've done, and then at the end I'll talk about a full-scale installation that's currently running in Chile. So first, on a row of 10 cubic meter cells in gold, this particular client actually wanted us to test the fine recovery and the coarse recovery on this particular cells and what the power draws were. And so we looked here, you can see the cyclone overflow, which was the fine, and the cyclone underflow, which is the coarse. And each row of 4 had a split feed that we looked at. In each case, the next step had a better performance when compared to a regular configuration. The plant trial that we went to next was 160 cubic meter cells, so an order of magnitude larger than we were looking at before. And these were self-aspirated Wemco type cells. And we replaced the first 2 cells in 3 of the rows left the fourth row the same. One row had two cells that were replaced with the next step rotor-stator combination. One had a high-powered WEMCO-induced air, and the other was an Excel, which is a different type of a mechanism that's used for flotation. In this case, the next step rotor-stator combination had 40% less power draw and actually a little bit better copper recovery. Next, we looked at a 250 cubic meter installation, row of 6. It was in a lead zinc operation. You can see here a picture of the surface. It's very stable. We replaced the first cell of a WEMCO self-aspirated row with one of our next step rotor-stator combinations, and in the next row beside it, we had the mechanism, WEMCO mechanism, replaced with the Autotech mechanism, competitor mechanism. And in this case, we had as good a recovery in each of the rows, but lower power draw again. And lastly, we did testing at a 660 cubic meter cell, which is the largest operating cell in the world right now. And we did test work there. You can see the size, you can see the scale with the person standing next to it. And very good results there also. We had, the blue line is the actual feed PSD in a scavenger operation. So in a scavenger operation, you've actually taken out most of the particles that are that are floatable and that are in the slurry. And you can see that the red line follows the blue line almost exactly, meaning we're recovering all of the particles that are there and that are floatable. Lastly, we had a full-scale startup. This was an installation in Chile. These are a row of 5 300 cubic meter cells sitting next to a row of WEMCO-induced air cells. This row of 5 actually has much lower power draw and the same recovery. So the client is actually going to install another row of 5 next to this and improve their recovery and operation at this facility. So this is an industry best patented technology. The next step, rotor-stator combination. Again, the interesting rotor and the stator with the slots. And it has up to 40% lower power consumption with as good or better recovery. That's all I have. Do you have any questions?
Okay, thank you. Some question? I think most.
Where do you manufacture?
We have manufacturing sites all around the world. We can make the rotor-stator combination either rubber covered or urethane, and if we make them out of urethane, our main manufacturing sites are in Australia, Chile, and the US.
Please use the microphone, please. Yeah, no. Okay.
Thank you for your presentation. I understand when you highlight the efficient.
As a global leader, we at OCP believe that working together is the key.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
En donnant en 2012 le coup d'envoi de la construction de l'Université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohammed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. l'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur-manager, futur ingénieur-manager, de se retrouver, mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohammed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
The world is changing, populations are growing. And by 2050, there'll be another 2.4 billion mouths to feed. So if we can do more to help more farmers grow more food, more sustainably, on all types of soil, we'll be contributing to a better future for all. As a global leader, we at OCP believe that working together is the key to ensure a sustainable and prosperous agriculture. We push the limits of science and technology for sustainable agriculture, not only for us, but for future generations. Using our expertise to transform Morocco's precious resource, phosphate, the work we do is of vital importance, constantly looking to create innovative fertilizer solutions across the whole value chain. Mining, refining, transforming, and creating products for the benefit of people worldwide. Phosphates are vital to the development and growth of crops, and so the fertilizers created from phosphates are of growing importance to global farmers, where strong root growth has become an ever more critical factor. That's why we don't just mine better and smarter, or even refine our production techniques to produce better performing fertilizers over a wider range of soils. We also mine new ideas, refine them, and then spread them to all four corners of the globe.
J'ai la chance de participer à l'exécutif MBA de l'Université Mohammed VI Polytechnique et surtout la chance d'avoir accès à une formation de qualité internationale fournie par des professeurs reconnus mondialement. L'objectif de l'Africa Business School est de former les futurs leaders africains. Car en fin de compte, l'Afrique n'est pas seulement une source des ressources naturelles ou de la main-d'œuvre à bas prix, mais surtout, demain, le contributeur à l'excellence académique, scientifique et business au niveau mondial.
En donnant en 2012 le coup d'envoi de la construction de l'Université Mohammed VI Polytechnique, Sa Majesté le Roi, que Dieu le glorifie, lançait un modèle innovant et intégré de complexes universitaires. Située dans la commune de Ben Guerir, au cœur de la ville verte Mohammed VI, l'université s'inscrit dans un projet d'espace urbain qui privilégie la qualité de vie et le dynamisme économique. Elle s'appuie sur les infrastructures de la ville verte et rayonne autour d'un écosystème de pôles d'excellence créateurs de synergie. Fondée pour la recherche et le développement, l'université propose un agenda qui répond aux défis économiques et sociaux du Maroc et du continent tout entier. Elle offre un environnement exceptionnel qui favorise l'expérimentation et les formations de pointe et ambitionne d'attirer les étudiants les plus brillants. L'objectif, devenir une université de classe mondiale au service de l'Afrique. En contribuant à la formation des futurs leaders du continent, l'université mobilise des chercheurs de haut niveau, parmi lesquels des membres de la diaspora marocaine qui ont fait leurs preuves à l'étranger.
Je suis très heureux d'être venu dans mon pays natal après des années d'expérience et je suis fier de participer à ce projet structurant pour notre pays qu'est l'université qui porte le nom de Sa Majesté le Roi Mohammed VI. Je veux mettre à la disposition de cette institution mes expériences passées dans le domaine des biotechnologies.
After 27 years abroad, I decided to join University Mohammed VI Polytechnic as a professor. I'm especially honored by the opportunity to serve my country and to contribute to establishing innovative and application-oriented research and a startup culture. So our first planned startup will be in the field of nanoengineering. The goal is to serve OCP and other industrial needs in corrosion protection and surface treatment.
Les défis sont nombreux. Sécurité alimentaire, développement économique, industrialisation durable. L'université adopte une approche qui stimule l'expérimentation, l'interdisciplinarité et l'esprit d'entreprise. Avec un objectif, valoriser les résultats de la recherche-développement en fonction des besoins de chaque territoire. Dans une démarche de développement de partenariat, l'université a déployé des programmes de recherche avec des universités et instituts spécialisés au Maroc et dans le monde. Des programmes qui devraient contribuer à transformer le Maroc en un pays à l'avant-garde de l'innovation et participer à la diffusion du savoir en Afrique.
We would like actually to concentrate on digital soil fertility mapping and addressing key soil health and fertility issues in target countries where OCP is working.
Les Living Labs, sites d'expérimentation de l'université, sont la pierre angulaire de ces programmes. Ouverts à la communauté scientifique, ils permettent aux chercheurs des universités de tester des solutions à l'échelle réelle dans des domaines clés. La ville verte propose un modèle urbanistique à forte valeur ajoutée écologique, avec une gestion optimisée des effluents. Le Green Energy Park accompagne le Maroc dans la mise en œuvre de son plan national de développement des énergies renouvelables. La Advanced Technology Mining Platform offre la possibilité de tester de nouvelles techniques d'extraction et de valorisation du minerai. Le Chemical Hub de Safi est un lieu d'expérimentation pour la fabrication des engrais de demain. À travers ces Living Labs, c'est tout le fondement de la formation et de la recherche appliquée qui s'exprime, learning by doing. Ce contexte favorable à l'entrepreneuriat encourage la prise de risque avec des projets de start-up en développement.
Les activités de e-tech tournent autour de la création ou bien le développement des projets technologiques dans des domaines variés comme l'aéronautique, les technologies de l'information, la robotique et essentiellement les énergies renouvelables.
Ancrée au Maroc, l'université Mohamed VI Polytechnique vise à créer un véritable écosystème du savoir à travers l'animation de réseaux dynamiques de recherche. L'université se donne les moyens et le temps de former ses enseignants-chercheurs à travers des projets de recherche et développement, des accords académiques et des conventions avec des institutions de renommée mondiale. Cette ouverture crée un effet d'entraînement et contribue à renforcer les capacités de la recherche et de la formation en Afrique. L'université construit des liens solides avec le monde académique du continent.
I'm currently pursuing my executive MBA at Africa Business School of Mohammed VI Polytechnic University, which focuses on some of the pressing challenges facing the African continent. This program, which is truly transformative, is designed to prepare the next generation of African leaders who are culturally aware and socially driven.
Ouverte sur le monde, l'université l'est aussi à travers sa vocation digitale. Elle développe des modes d'éducation innovants à travers des contenus d'apprentissage numérique et des cours en ligne ouverts. Elle permet la même expérience d'apprentissage par les étudiants où qu'ils se trouvent, Rabat, Casablanca ou encore Laayoune. Institution citoyenne et responsable, l'université veille au partage du savoir au profit des communautés, en adoptant une politique de recrutement socialement inclusive fondée sur le mérite.
Comme un grand nombre de mes camarades, nous bénéficions de bourses, c'est-à-dire que notre université est basée sur un modèle social très juste qui bénéficie à une grande majorité des étudiants et qui nous permet de vivre dans un campus très agréable.
C'est une formation dans l'ensemble très diversifiée qui permettrait donc à chaque ingénieur-manager, futur ingénieur-manager, de se retrouver, mais aussi de s'épanouir dans un environnement qui offre de belles conditions de vie universitaire, que ce soit au niveau du logement, restauration ou encore le centre sportif de haut niveau.
Premier projet marocain mené sous la certification internationale LEED, qui atteste de son excellence environnementale. Le campus de l'université offre des infrastructures, des équipements et des espaces de vie favorables à l'épanouissement de tous ses membres. Cité du savoir, de la recherche et de l'innovation, l'université Mohamed VI Polytechnique est fière de traduire la vision de Sa Majesté le Roi en faveur du développement durable du Royaume du Maroc et du continent africain.
SYMPHOS, tout d'abord, c'est un symposium international sur l'innovation autour de l'industrie des phosphates. C'est l'un des plus importants, les plus grands symposiums au monde aujourd'hui dans ce domaine. Cette quatrième édition donc, fait suite à 3 précédentes éditions qui ont permis un petit peu de développer un certain nombre de partenariats dans le domaine scientifique et l'innovation autour du phosphate. Cette année, la nouveauté, c'est qu'on l'organise dans une prestigieuse université, c'est l'université Mohamed VI Polytechnique de Ben Guerir. Nous avons accueilli aussi dans les 105 exposants à travers le monde. Ils viennent des États-Unis, ils viennent de la Chine, ils viennent de Singapour, ils viennent de différents endroits du monde pour promouvoir leurs produits, leur savoir-faire et partager ce savoir avec le monde industriel, le monde scientifique. L'objectif, c'est donc, comme j'ai dit, une agriculture durable pour le bien du monde.
When I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what you are putting bricks to build a future, and I think it's really fascinating, and I believe the rest of the world would need to know more about it. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me, and I learned it today, and I feel very happy, and I'm glad to be part of it.
We're about to enter the second plenary session, which is going to be presented by Professor Bruce Rittman of Arizona State University. He's a professor of environment engineering, and he will talk about, well, quite appropriately, about biotech and its role in making the phosphate industry more sustainable in the future. Also, of course, don't forget to ask all your questions in the comments or on Twitter using the hashtag SYMPHOSLive. Tune in to our live feed on YouTube and on LinkedIn. And also, don't forget to tweet at us if you have any questions, any remarks, anything you want to share with us. Use hashtag SYMPHOSLive. Hashtag SYMPHOSLive. Thanks a lot for following, and we'll see you tomorrow. Thank you. Hello, Professor Ramakrishna. I'm sorry. Well, we've had a very interesting talk on your behalf, and we saw it live actually on SYMPHOS TV, and we were having our own talk. Thank God it was off camera. I'd just like to hear your impressions about being here in Ben Greer and discovering this university, and what do you think about this type of event and how it helps actually our industry make a better world?
Well, I think when I first came here, of course, this is my first visit, and the moment I alighted here, I realized, and it really fascinated me, what you are putting bricks to build a future. And I think it's really fascinating. And I believe the rest of the world would need to know more about it. And what I saw so far, you have been systematically putting together a strategy and building on that realization in terms of developing the talent and making them relevant to the future industries of not only this region but for the whole Morocco. And I also understood that these institutions are also trying to integrate as many people as possible from Africa for the innovation, which I think is a really eye-opener for me. And I learned it today, and I feel very happy, and I'm glad to be part of it.
We're very glad to have you here, and I think you put it best. But yes, we have to adapt ourselves to the future so we can actually make it. And we'll let you go. Thank you very much, Professor. And we'll see you around these 2 days. Thank you. please introduce yourselves?
I am Muna Bamoumen. I am Hajar Hilali. And I am Mariam Bamoumen.
Hi guys, we're back live here at SYMPHOS from the poster presentations area. Hi guys, we're back live here at SYMPHOS from the poster presentations area where some PhD students are presenting some pretty exciting research that they're doing in the domain. So we're just gonna move to them and let them do the talking. Well, first of all, would you please introduce yourselves?
I am Muna Bamoumen. I am Hajar Hilali. And I am Mariam Bamoumen. And we are PhD students at Emins in Mohammed VI Polytechnic University.
Okay, thank you very much. So I'd just like to ask you what type of research you've done here, and well, just tell us a couple of words about what you found out.
Yes, this paper presents the problem of blending ores to meet a certain demand of clients. And our approach deals with dynamic blending that takes into account several parameters.
Several parameters such as grade request and the variable chemical characteristic of inputs, and our developed approach aims to minimizing the consumption of rich inputs as well as the minimizing the cost of non-value added activities and ensure the flexibility of blends. And all of this is in order to ensure intelligent and economic confrontation between supply and demand.
Thank you very much.
And our mathematical model is a mixed integer linear program using the Express IV software.
Okay, well, thank you very much. This all sounds very impressive, and I wish you the best of luck for your PhD. Good luck. Now we're gonna move on to our next presenter, who I'm gonna let introduce herself.
My name is Najat Bara. I'm a PhD student at EMIN, School of Industry and Management in Mohammed VI Polytechnic University.
Well, can you tell us a bit about your research and your paper that you have here?
This paper presents the architecture of an interactive scheduling decision system, allowing the users to find an optimal solution on fertilizer production system. So our approach takes into consideration a lot of constraints such as delivery date, launch time, preventive maintenance, and the impact of scheduling on supply chain management. So the approach begins with a local optimization on the fertilizer production lines, and it moves to a global improvement of the supply chain by taking into consideration the constraints on the upstream of the supply chain, which depends on the availability of inputs, and the constraint on the downstream of the supply chain, which depends on the storage space. So the deliverables of our solution is the scheduling of orders on lines of fertilizer, the evolution of acid consumption, and the evolution of production of fertilizers.
Okay, well, thank you very much, Najat. This is very impressive too, and I guess supply chain management is very important in any kind of industry, and especially in mining and phosphate transformation, I guess. Well, thank you very much to all of you for your time, and guys, keep watching.